Let's see. Seems to all be running. Hope you guys can hear me. Good evening, everyone. Morning, if it's morning in your area of the world. Death Stream 8 already. Can't believe that we have been working on this for 8 weeks today. All right. I can see that. Oh, that's funny. I actually got my sound mirrored on my headset now, so I am getting a beautiful commercial playing on my headset that's sitting next to me. So that caught me a little bit off guard. So yeah, hopefully everybody can see me. Hopefully everybody can hear me. Hopefully there's not an echo from this thing coming around. So I am going to turn this off because it seems to all be working. There we go. All right, Death Stream number 8 tonight. I haven't really spent any time on our little project this week. Been kind of busy at work, and been spending some time on the next tutorial that I'm going to be hopefully releasing this weekend if everything goes well. So that is going to be the next part of our weapons tutorial. I've recorded all the footage. I just need to record the audio. And then put it all together, and hopefully I can publish that soon. So that one is going to be about the two-handed holding of our sniper rifle, so that you can stabilize your aim a little bit. But I don't think that's going to be the end of things. It actually needs more to make things work a little bit better. And I'm not quite sure yet where I'm going to go with that. I might actually do a stream purely experimenting with the sniper weapon at some point in time to see if I can try some different things to solve some of the remaining issues that I have, and come up with something that can then be turned into a proper tutorial to kind of put the final part in that in the whole aiming with a sniper and aiming down sights. It's actually quite interesting how much vibration it is. Also because of me, I'm not the most steady-handed person, so I'm pretty sure that someone who does have that will have a lot less problems holding a weapon in VR. But for me, unfortunately, I still do get. It is quite hard to aim at very distant things and keep your gun stable. And maybe that's just the way that it is because you're holding controllers. You're not actually holding a proper gun. I know that from the aim controller that I have on my PSVR is a completely different experience. And again, I don't know exactly what's that game called? Farpoint, I think. What they have done to improve that. That's something that I need to see if I can research that a little bit more. But it's a lot of fun, that I do have to admit. It's fun trying to chase down solutions for these problems. Okay, Island Jan was here already an hour ago. I hope you haven't been staring at a blank screen for a whole hour. Welcome, Master Ox. Welcome, SS Lex. Show me your bug. It's not a bug. It's just that it still shakes a bit. That it's hard to aim, and that'll all be in the tutorial, so you'll be able to see that. So yeah, it hasn't left much time this week to actually work on our little space game. So that's pretty much still where it is today. I was originally thinking about continuing with the missile system, but I really want to spend a little bit more time outside of the stream to just sort of polish up what we did last week. So I'm going to leave that where it is right now. I am pretty happy of how well that works. There's a couple of things that we'll need to readdress, looking once our enemies start flying around, making sure that it actually can still hit them, because it's right now too easy for the enemies to fly in a direction that the missiles will always miss them. So those are sort of like the things that we still need to work at. The other thing that I really need to start spending time on is improving the aim of the lasers and any other weapons, so that you can get more visual feedback there. But we need to get our NPCs moving if we want to do that. So that, I think, is going to be the topic of tonight. Is going to be looking at getting a very simple AI working in our for our enemy planes. So yeah, hold on for a quick. Let's switch over to that one. Alrighty. Shout out, by the way, to Nathan from GD Quest, who did some really nice videos about state machines and stuff like that. So I've been watching those just to get a bit of some ideas. I'm not going to follow his example exactly, but I am going to incorporate some of those ideas into what we're doing here. So when we are looking at our enemy craft, we have our scene here. And that scene is directly extended from our friend or foe script. And I really want something to be in between there. And that might still be something that we're going to be using for both friendlies and enemies. I'm not quite sure yet. But I don't want to plug the main state machine into the base script, because we're also using this for our player. And right now, I don't actually believe that our player script requires a state machine to do the things that we're doing because of the type of game that we're making. I might change my mind on that. I'm not quite sure. So the first thing that we're going to do is we're going to put a script in between these two. And unfortunately, that is a feature that our good friend Godot doesn't have internally. So we need to do a little bit of trickery to make that happen. First step is going to be easy. Extending the script to create our basic AI script. So we're going to go for friend or foe. There we go. And I'm going to rename that to friend or foe AI. And we're going to save that. I'm just going to save that right next to our friend or foe script. And that also means, go away bar. That also means I want to extend my my GD script on that and create a new model there. Let's just get rid of all that. So we're going to put some code in there later on. I'm also going to go and clean up a bunch of things here, because there is a lot of stuff in here that we currently do not want or need. Actually, you know what? We're just going to do close all and start over. So I'm going to keep that one in there, even though we won't be doing much here, will we? Not sure yet. We shall see, we shall see. I don't think so. I think all the logic that we're going to be writing today is going to be in the friend or foe. Thing that we need to keep in mind is that we made this a tool script, which we should also have done over here. So there's our bomber, it's also a tool script. So we have to make sure that our AI script is also going to become a tool script. Else the chain breaks and we don't get all the in editor logic. So we have to also make sure that we skip all the stuff that we're doing here once we're when we're working in the editor. Alrighty, just double checking that everything is going right on screen. I can see that the editor is visible on stream, so that's all good. Guys, let me know if the sound is going to stay all right, because I did change a few things around so that I can actually hear the sounds in the game in my headset. I hope that isn't going to start echoing in any way, shape, or form. We'll see. Alright, where are we? So the first thing that we need to do is make sure that we change this one to actually go and inherit from our AI script, but we can't change that in our Bomba script itself. So that is something we have to do behind the scenes. Oops, that is my script for my my video. Oh, you get a little sneak peek there. There we go. That's the one that I need. That one can close. Space, models, enemies, bomber. So somewhere over here we have that it imports our friend or foe scene. So we can just change that to AI. And because that resource has ID 2, we can see that here we're instantiating that resource, and that will be the right one. This is also, by the way, if you create a script and you later change your mind that you actually want that script or that scene to extend another scene because you want to move some logic into a more generic part that you want to reuse, it's a matter of adding one of these lines at the scene text file at the top and then adding that instance line in here. So a scene, you can actually quickly look at our base scene here, doesn't have anything that extends it. And then our first resource, because these are all the sub-resources. So our first resource here, node, name, friend or friendly. Here we don't see that we're an instance. Here we're seeing that we're a type. So this is the difference between a normal scene that's not extended from or not inherited from another scene, and a scene that's inherited where we have that instance. And you can edit that and change that if you want to. It's a nice thing about the fact that Godot scene files are text-based, so you can edit them in that way. They're quite readable. It does pay to have a look at how they're structured and get familiar with it. And you know, it helps because you can easily fix things up that you just can't do in the editor. Not something you would regularly do, but from time to time it does. You know, it is a lifesaver. Alrighty. So we now have our AI script in the middle. I'll leave that open. I don't need you. I'm not quite sure why that opened. Friend of foe. So now if I go and edit that one and I go to there, we actually go to our AI script. So I'm keeping that one open just as a reference, but we're now on that one. And then here is our ship. All right. So the first thing that we're going to add here, and these are going to be normal nodes because we don't want any 3D logic here. These are just structural things to organize things. Is in our AI, we're going to create a node called states. And that becomes a place where we can put all the states that we actually want to support and that we want to do something with. And that is what we shall be using. And that's how to introduce a state machine. I think it's easier to just show how it works. The basic idea is that our NPC is going to be in a given state that will control how it behaves. So what we're going to be doing right now for our first iteration here is we're going to make our bomber. We've got 3 of them right now, which is actually the wrong number, so I'm probably going to change them to 4. And what we're going to do is we're going to have 1 flight leader, 1 wingman. So the flight leader is going to have a default state where it follows a track, and its wingman is going to follow its wing leader. Unless the wing leader gets destroyed, then the wingman will start following the same track as the wing leader was. And we're going to have that as 2 different states. So state follow track, state follow leader. But then when our enemy finds us or one of our friendlies and decides I need to attack, we go and change our state to an attack state, which will then change the logic that it's no longer going to follow its path. It's now going to start flying towards us, and at some point it's going to start shooting at us. And we're going to play around with those states and switching between those states depending on what happens. For instance, if the shield breaks, we might flee. If we pass the player so that we now have the player behind us, we might do a dodge. It's all sorts of things that we can start thinking about. And you know, it kind of it narrows down how the NPC behaves to very small building blocks, and that keeps it manageable. And even with some very simple states and interaction between the states, you can get some really complex organic logic behind your NPC. So let's see how we can make that work. All right. So the states are going to be represented by nodes underneath our states node. And that allows us to put the logic against it and have an easy way to switch between them and to make them work. And that's going to be controlled by our main friend or foe script. And the first thing that we need to control is to, what do you think? I'm wondering if I should make this an export variable so that we can set it or not. But let's just start with, let's just actually start with this, it being a normal variable. So the first thing that we want to do is we want to keep track of what is our current state. starts off as null. We don't have the current state when we start. All right. The other thing that we want to have is a state stack. And that needs to become an empty array. So when we change states, we are going to have two options. One is that we just replace the current state that we have. So for instance, if our AI is attacking our player and it flies past our player, it might do a dodge. So we change the attack state to a dodge state. Until the dodge state is completed, we might go back to the attack state, or it might then go back to whatever base state it has. But when we look at the state, for instance, following our path when it hasn't found us yet, that's going to be a state that is going to be its default state. And when it then finds us, we will add our attack state on top of that, so that if it loses track of us and it can no longer attack us, it just goes back to whatever state there was before. So we're going to stack those in a state stack. And for our wingman, we're actually going to start with the follow the path state, but we're immediately going to add on top of that stack the state follow its wing leader. And it's going to keep following its wing leader until the wing leader is destroyed, in which case it then automatically goes up the stack to the follow path state. So that's how we're going to create that behavior, that once the wing leader is destroyed, it becomes a sole survivor, and it's going to inherit a behavior as a result. Alrighty, so we've got a current state, we've got a state stack. Then we need to go and can we do that with an array? Do we have a typed array in GD script? That's something that I wonder about. I wonder about that. Does anybody know that? Can I, in GD script typed array? I just want to see if we have an array of node references. Static typing. Here we go. That's all. Where does it say about arrays? Type to dynamics. Well, we're mixing them. Haha. So here we just got a normal array, but that's not a typed array. That's an error. Well, we're only going to have two default states. So let's just start with export node path var default state. And maybe we'll have a default extra state, we will see. We're going to start with that. We obviously need a function to change our state. And I'm using, new states. I'm using node paths here because we're going to be adding our states as nodes here. And that makes them easily accessible for what we're doing. So that's going to be our new state. There we go. If we have a current state, we're going to be doing something. We'll add that logic in once we start building up our states. Then we're going to go and change our current state. Oh, I actually want to go and make sure that I've got that like this. So let's also say No, we're never gonna get that we're gonna set it to a non-existent state. I don't think that's a good idea. Get node, new states. Or are we always going to go and... No, I actually want to... Let's actually do that first. So let's go save that. We're gonna go over here. Let's create our first state. That's probably a good idea to start with. Come on. Are we still running? No, we're not still running. We crashed. Wow, that hasn't happened to me very often. All right. I guess it didn't like what I was doing. It's probably because we have a tool script that wasn't being compiled properly. So let's go back into our enemy scripts or scene. There we go. Go there, friend of foe. Let's start off. Let's go actually, because I think I can just create it as such. So let's create a new script, which is going to be in models. You know what? I'm going to create a folder states in here. Because of course we're going to implement these to be generic as much as we can. We're going to call this one base state. There we go. Da-da-da. Create. Let's take that all out. This is going to be our implementation. Now, the thing that I was wondering about is, can I register this as actually, let's call it AI base state so that we have a class name. And let's add an, we call it init, or do we call it start? No, let's call it init or enter. We call it enter. Exit. Let's start with those two. So here we can now say current state dot exit. There we go. That means that our current state, we can actually go and, oops, I can't type, base state. Look at that. It knows that class now. So we've classed our base state and therefore we can pass our base state. It also means I actually want to pass our base state here. There we go. And now we can put our current state to our new state. And I'm pretty sure there's going to be more setup that we need to do here, but it's just to get a start. I think we call it enter. All right, so we're changing the state, making sure that whatever the current state is, it gets an exit, so that it knows that it can do any sort of cleanup that we want it to do. Then we remember what our state is, and we add that in. Now the other thing that I want to do here is add a variable here called push state, which is going to be a Boolean. And that means that if that is true, we're going to go and, oh, that also means that this needs to be, let me think, current state, exit. So push state, we're going to put it on top. So if we're not going to push the state, we actually want to do state stack pop. I always forget, is it pop front or pop back? I think it's pop back. Let's go and have a look at that, because that would be very foolish if we get that the wrong way around. All right, that's push. I need a pop. Where are my pops? Here we go. Removes and returns the last element. Yeah, exactly. That's what we wanted. So we're going to remove the one that's on top if we're not pushing the state. So we're replacing. And in this case, we're always going to say state stack push back current state. So we're going to add our current state to our stack, so we know which one's on top. Hey, Mr. Game Endeavor. Ah, How you going? Yeah, yeah, you are indeed correct. Game Endeavor has got a really nice video about this topic as well, I believe. Not sure if I watched it. Should probably catch up on that. It'll be interesting to see how we compare in that. Most part, I am building this on the fly, probably getting it wrong the first time around, but that's why we're doing this. Learn as we go. All right. All right, so on our ready, and this is where I do need to have a look over here, because I always forget what the code is. Okay, here we go. So I want to make sure that we don't do any of this in the editor. We might at some point do something in the editor there that we can see some more stuff. I'm not quite sure. But here we're going to say if default state, which we really always should have. Then we're going to do change state get node default state. Now, if for whatever reason that one doesn't exist, that would be very sad. But that would actually not really matter. Oh, in this case, we don't actually really care. I'm just going to put true because we're not going to have a current state when we call this for the first time. Oops. Let's put that in the right place. My throat's a little dry tonight. Apologies for that. It's been one of those days where I have already talked way too much. Anyway, obviously there won't be a current state, so this bit of logic will not be executed the first time we call this. And if for whatever reason our default state is not set up, then obviously we won't have a default state, and well, that's the end of the story for that. Cool. So we need to get our first state going, and we're just going to be doing that for just one of our NPCs. Actually, come to think of that, as I said before in my introduction, educating brute force. That's a nice way of looking at it, D-Chan. Sometimes you just gotta try stuff and see where you end up with them. So, like I said, I actually really want to have 4 of these guys so that we have an even number, 1 leader, 1 wingman, times 2. Yeah, they're nicely in order, so we can make these guys the wing leaders and these guys the followers. Alrighty. Now, one of the things that I also need to find out one of these days is whether we can set export variables that are actually not published outside of the extend scripts. But it's probably too much to ask. One thing that we could do is put some of the logic into a what you call it? Like into a subnode, but then I need to do some ugly things in how it interacts with certain things. So we're not doing that. Not today. I want to get that in between. There we go. So our actual states for our enemy are going to be defined as a subnode over here. So we're going to start with adding another node here. And now we need to create a new script. Actually, we're going to load our base script first. And now we're going to extend this script. And we're going to, oh, I should have renamed that, by the way. Actually, before we do, we are going to do that the other way around. So I'm actually going to call that AI follow path. And I'm actually going to save this as a scene. So where's my save branch of scene? In our states, so AI follow path, boom. There we go. And then in here, I am now going to extend my script. And we're going to cut that. And this is where we're going to be implementing our actual logic for this state and what this state will do. Which we will do shortly, not yet. Now that we have that, we can go and assign our follow path here. There we go. Boom. That looks good. And that's going to make sure that that is going to be our default state. Now, yeah, we're going to worry about the wingman logic later on. Right now, they're all going to follow a path. They just don't have a path right now. So that is actually one thing that we should do over here is export. I think that's just path. Follow path. No. There we go. Alrighty. Let's see. Let's start seeing 3D. So the idea here, I think we need to copy that one over because our follow path is going to be set up here. Alrighty. So that means we are going to also want to do that same line over here. Here we go. Boom. Boom. Export hint is, that needs to be a node path then. This is the only thing that I don't like, is that you can't state what type of node path you actually want. It's a bit of a shame. All right. So in this case, we want to do a set follow path because I want to have an internal method here. Follow path node. No. Yeah, that's going to be working. Oh. Func set follow path. Follow path. Maybe a node path. There we go. Follow path. No. Node is get node follow. Do we actually want that? No, you know what? Here we're actually not going to make that an export variable. Here we're simply going to set follow path. Follow path is going to be a path. Oh. Here's a new follow path. Okay. So the reason I'm doing it this way is because in our start scene, we're going to be assigning the follow path that our enemy needs to follow when they don't have us in view. But obviously I can't set it on the fighter itself because the different enemies will have different paths, especially once we go through different levels or different areas of a level and we encounter different enemies, we spawn in new enemies. We might want to assign different paths for them to follow by default. All right. But that means that we do need a ready function here. And again, this is the only thing that I don't like about tool scripts. They're really powerful because we can make sure that we can set things and have the editor react. But then when you have logic that should not run in the editor, you gotta always check for that. It's a bit dual. But, you know, small price to pay, I guess. So that one is going to be on our states. Set follow path, get node, follow path. There we go. If follow path. I'll make sure that we only call that if we've actually got one set. Can we go down, please? All right. So now we get the situation where when our enemy spawns in or gets created in our ready script, that always gets called when all our nodes are fully constructed. We're going to tell our AI follow path what the path is that we want it to follow. Okay, cool. Where's my drink? All right. Now, one thing that I'm interested in, print. I actually want that over here. This is just something that I am curious about. Which one of these two gets run first? Let's just quickly run this. Oh yeah, I made this full screen, which in this case is a bit of a bummer. All right, so the AI gets called first and the bomber gets called next. That's cool. I'm happy about that. All right. So we can have our AI get our default state set, and that will run first. Cool. That means that we could create our wingman node here. We can actually then add that change state after we set this up, and that'll solve that problem. But we're not that far yet. Okay. So this is probably going to be fun because they're going to probably run into each other. Oh, that's not what I had in mind. We now need to go and create a path. And path is just a node that is a container for a curve. Now, one of the things that I didn't like is I actually want this. I'm going to use this as a trick to position it. There we go. All good. I just want to position our path on our first guy so that we have our beginning place. All right. And now we're going to add a new curve 3D there. And that will allow us to set up a path for this guy. Now, I'm going to have all four follow the same path for now, which means that they're going to try and bump into each other. It's a start. It's okay. Okay. Let's get a top view here so that we can more easily set our nodes. Let's select add nodes. So we're going to start with having a point over here. And we're going to have a point over there, 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 there, there. Cool. And I think there's a close curve there. Yep. And now we're going to use our select. And we hold shift so that we can turn these into nice little Bezier curves. Now, unfortunately, with a closed loop, our beginning and end point don't really do that too nicely, but that's okay. We're just going to play around a bit with it. Oh, that's not what I wanted. That's what I wanted to do. Now you can't really do that too well with the one that we start with, so we're just going to angle it a little bit like that. It's not exact science, it's just to make it look somewhat nice. Not have it turn sharp things. In the end, it's not going to follow this path exact. We're going to use this path as a guide for our AI to steer towards. So it's going to be overshooting this line anyway. Which also means that we probably want to have this guy a little bit less like that. That's all right. Just have him go a bit more like that. That's a funky path. All right, cool. Now, the reason why I went into top view is if you are moving these points in perspective view like this, it's actually really hard to position them properly. So for now, that is just what we wanted to do. We're going to want it to follow that line around, and we'll see how it goes. So we're going to start with our first bomber, and we're just going to make him follow the path. We're going to leave the other guys where they are, and just get it to work for our first guy. Okay. Still need to update that. That's fine. All right. So how is our little bomber going to follow our line and fly in little circles? Good question. And that's going to all be in our follow path. Okay. Still wonder if I want to have an export here just for completeness sake. Nah, we'll just do it like this. Okie doke. For that, we're going back to our base state. Now, actually, we're first going to go and have a look at our friend or foe. I don't think I've got any logic in our friend or foe for what it is doing here, which is fine. Okay. Now, if we look at my player, I still need to rename some of these classes. There we go, my plane script. Obviously, when we are controlling our plane, we're doing a few things, and this is why we have a handle control input and target input, handle lock, handle fire, all that sort of stuff. And that's controlled from our physics process and our normal process. And in our physics process, we're doing all the actual logic for the plane flying around. And in our process, we're doing the type of thing that the user doesn't have direct control over. So the fact that we selected a target and all that sort of stuff. So I think that for now, for AI, we're purely going to be interested in doing things with our physics process. And what we want to delegate here is we want to have that logic in our AI script and have it figure out what it is that we want to do. So in our base state, we're going to add a function called handle physics process. And we're going to give our delta there. And we're just going to have a pass in our default script. Now, the other thing that I want to do here, do I want that yet? No, I'm not going to be worried about that just yet, so it's fine. All right. All right. Yeah. Okay. So that means that we need to go and pass off our. All right. Hang on for a sec. There we go. Create some space that we can actually see what we're doing. No, not our process, our physics process. There we go. And what we're going to do here is we're going to say if we have a current state. That's a little noise in the background. Then we're going to call our handle physics process, and we're going to give it our delta. So whatever our current state is, we don't really care about our underlying state, whatever's on our stack. We only care about what our current state is. And we're going to tell our current state, you are going to go and handle the physics process of our little NPC. Okay. So that means that we actually want to have this implemented over here in our follow AI. And we're basically going to do a similar thing to what we would normally be doing as if we are, you know, a person, a human being. All right. So bit of noise in the background. I think my kids are going to bed. Very good. Okay. So the idea here is we're going to find out what the closest point on this path is in relationship to our fighter. And then we're going to figure out some heading away from that, down that path for us to fly towards. So we're going to have like a target spot that we want to go and fly towards. And we're going to go and steer our ship into that direction. The other thing, of course, that we're going to do is we're going to make sure that we're going to apply a acceleration force. You know, our ship needs to go forward. No, I want to go back to our playing script. Because I want to have a quick look at what are we doing here for throttle, because that's actually the simple one. So we've got a thrust factor of 1. Let's see. So that's just going to give our throttle. Okay, that's going to be 0, 1, and we got our thrust factor. I'm surprised that our thrust factor is just 1. So we're not really giving it a lot of boost. Did we overwrite that in our fighter? That's the question. No. Okay, that's fine. Fine with me. So let's go and do that here as well. So we're going to do this in 2 steps. We're going to step 1. Forward. We're going to just gun it. And then we're going to steer towards our follow points. All right. So our keep moving is going to be easy. That's just going to be our apply impulse. So again, I'm just going to cheat and have a look at what was the code that we do here. Just a central impulse along the z-axis. Okay. Let's also go and so that's going to be a float, I'm guessing. Thrust force. We're going to default that to 1. That's fine. And we're going to do apply. Oh, hold on. That is the other thing that we need to do. We want to go and that one we are going to do as a node path. NPC. We obviously need to know who the NPC is that we're controlling. Or are we going to send that through our handle physics? I think that's actually a much better idea. We're going to do NPC. That's going to be our rigid body. And that is going to be a float. And obviously I need to make sure that we also set that on our base. There we go. And that means that in our AI, we're going to send self there so that we have access to our NPC. Now we can say NPC dot apply central impulse NPC dot global transform dot basis dot z times thrust force. There we go. And basically the assumption that I'm making here is because we've got on our bomber because we have a velocity dampening here on our linear as well, 0.5. That means that at some point we're going to reach an equilibrium between the ship thrusting forward and the amount of drag that it receives. and that will automatically give it a maximum speed. So it's basically always trying to reach that maximum speed. So I'm not going to check for a speed that it is and then say, well, hey, stop using your engine once you reach that speed. We're just going to say, keep gunning it, and at some point it's just going to go for a maximum speed. At some point we might play around with that and say, well, we're going to have a target speed, and once it reaches a target speed, we're going to cut out the engine and it's just going to coast, and we're happy with it. But for now, we're just going to let it go itself. Hi, Philippe. How are you going? GTA 7. Well, if GTA is ever going to go into space, then maybe. I don't think we're going to be stealing any spaceships floating around in space or anything like that. Is GDScript better than C# on Godot? That, I think, is a very personal question. Depends very much on your background. I think if you are an experienced C# developer, you probably have a lot of benefits trying to use C# with Godot. If you are not, then I would always recommend you try out GDScript first, because, well, for starters, I'm a C++ programmer. I have done C# in the past, but my main language of choice is C++. I would never build a game in C++. Just way more work than is necessary. Obviously, the engine is C++. I will do performance work in C++. But for this sort of stuff that I'm building here, this isn't going to be affecting performance much. And the nice thing about GDScript is it is so well integrated in this engine, and it's so easy to learn. I think for anybody who is just making a choice, what language do I want to learn to write games in Godot, I would always say go and learn GDScript. There's more information out there. There's more tutorials out there. You're going to get up and running much quicker. You're going to learn it really quick. And it's a really fitting language for what you are doing in Godot. And unless you're doing really crazy stuff, you're not going to run into bottlenecks. If you make that next step and you do run into performance bottlenecks, or like I said, if you already have a C# background and you want to utilize your existing C# knowledge, especially if you enjoy working in C#, then by all means go and play around with the C# version of Godot. Go and use that. It's a little bit more setup. It's a little bit less forgiving than GDScript, but you do get the advantage that you can write more complex code in C# without it having a performance impact. So if you want to do things like mesh manipulation, or you want to do terrain generation or things like that, you probably are going to want to either switch to C# or, like what I do, is build modules in C++, just build GD native modules in C++. And again, for me, choosing C++, it allows me to leverage GDScript, use GDScript where I'm just interested in control logic, where the impact on performance is non-existent because of what we're doing here. And then use C++ for the core stuff that I need to do. But if you're using C#, you kind of get that out of the box, because you can write that performant code if you need it. But in the end, it really is personal preference. For anybody who's starting from scratch, who is new to programming, who's new to game engines, I think you'd probably do yourself a big favor if you start with GDScript and learn that first, and you might find that you'll never need anything else. And it's just, like I said, the integration in the engine is just so well done. You're just much faster in building stuff. That's what you win. You lose a tiny bit of performance, and like I said, I don't think, unless you're doing something really crazy, that it is ever going to be something that's going to become your bottleneck and the reason why your game doesn't perform. 9 out of 10 times, if you've got a game that isn't performing, it is a design issue, that you take the wrong approach to a problem. Not the GG script, unless you're doing, like I said, things like terrain generation and stuff like that, high volume calculations. That's really where GG script hits its limit. But you're just much faster, you're much faster in building stuff with GG script. That is the trade-off that you do, is the fact that you're working inside of the editor. You can step through it, you can make changes, you don't have to go through any compile stages and anything like that. It just runs right off the bat, and that's really where you save a lot of development time and a lot of debugging time. So that's in my eyes where GDScript really is winning it from C#. Winter XX. Well, I'm hoping that eventually, once it starts working, it becomes a little bit more clear what it is doing. Do feel free to ask questions if you want me to elaborate on something that you are not following along with. This video will be rewatchable at any time, and I do keep a good eye on comments on videos. So if you want to re-watch it at some point in time to see if you can follow along now that the story is more complete. Again, this is not really a tutorial like I usually do. This is live streaming development. So we're making it up as we go. Feel free to leave comments on videos even after the streams are over. If there is anything that you see that you're interested in knowing more about, and who knows, maybe we'll condense it into a tutorial at some point in time. Alan, yeah. One of the great things is that some of the core developers, the new structure around how we are doing Patreon, and the fact that Epic gave Godot a big grant, which means that people like John are no longer paid out of Patreon; they're now paid out of the Epic grant. It's freed up. I think we're hiring 3 more people on a contract basis as part of the Godot organization. Don't hold me on that exactly. I don't know the exact facts. I'm not involved in those decisions. Just read what's happening and the talks that I have with the guys. The work that is being done on GDScript, even in 3.2, there's already a whole bunch of improvements in performance. But I think all the work that's currently being done, who is it that's doing it? Is it Gillis? I think it's Gillis who's working on all those things. Yeah, in Godot 4, there's going to be a lot of performance improvements in how well GDScript runs. What people often don't realize is GDScript was obviously created by Jean all the way back in Godot 1. So there are definitely areas that just haven't gotten the attention to make them more performant. And now they are getting the attention. So as far as runtime languages go, it's getting better and better and better, and definitely nothing. I think the biggest problem that people have is that they look at benchmarks, right? And when you write a loop in C++ and you write a loop, in GDScript, it's going from loop counting a value from 0 to 1,000,000. So it's executing a loop 1,000,000 times, and it's doing an action there. Yeah, C++ is going to be 100 times faster than GDScript is. But that's not what you're doing with GDScript. The thing that you have to keep in mind, especially in a game engine, is the biggest performance bottleneck is what you're actually rendering to screen, especially in 3D. So what you're going to be seeing is that you are actually rendering, you're preparing a frame. All the code that we're running in process and physics process, all that code gets done first. And then we start rendering that frame. Well, guess what happens the moment that you're rendering that frame? You're now going to run your process and your physics for the next frame while this frame is rendering. So if you've got a timeline and this is your rendering time, and here you stop processing of that frame and now you're rendering the frame, and all your GDScript runs in that much time, then from here to the end of where your rendering is finished in that, 1/60th of a second, or in our case, in 1/90th of a second, half the time your CPU is going to be idling. So it doesn't matter whether your code takes this much in C# or this much in GDScript, even if GDScript is half the speed of C#, because after that it's just going to wait until the rendering is done. Before then it goes on to processing the frame after that. So who cares if it's slower? Because it's not your bottleneck. It's not. And if as a result you scratch weeks of programming time because of how well GDScript is integrated in the engine, it's win. I don't get why people can't see that. Now, again, if you do something in GDScript that it's not meant to do, it's a control language. It's not, like I said, if you're going to every frame use GDScript to update your whole terrain or do LOD calculations on terrain, yeah, then you're going to run out of that buffer, that 1/60th of a second that you have to do all your processing. And then all of a sudden, if you go even a millisecond over that 1/60th, then all of a sudden you halve your frame rate. That's where your bottleneck starts. So that's something to be aware of. And again, I've noticed that even with our game here in VR, it's even more important because we have to do everything in 1/90th of a second. And especially physics. Physics is probably the bit that costs the most. And even what we're doing right now, the AI as well. If we're now doing AI for a handful of enemy planes, it's going to be peanuts. We're not going to be doing very expensive things here. But if we have 100 NPCs on screen, yeah, then we might start to get a problem. Then, depending on what we're doing in these state machines and how much processing we're doing, we might start seeing that we're actually going over that buffer that we have, over that amount of time that we have to process a frame. Yep, absolutely, Philip. Like I said, if you're an existing C# programmer, obviously you're going to have a head start knowing a language and just applying it into an existing environment. But the big problem that you have is there are so few people who are really putting their time into this. It's hard to find documentation. It's hard to find tutorials. The best advice that I can give you if you do want to go down the C# route is to join the Godot Discord. They do have an incredibly active C# channel on the Discord server. And there are a lot of people there who are doing their stuff in C#, and who can give you a lot of advice on how to do things. VR-wise, on the VR channel, the XR channel on the Godot Discord, there's even someone who is writing a complete VR game in C#, and using actually very little of the scene editor because he's trying to do a Doom clone. Sorry, is it Doom? No, Wolfenstein clone. Using the original Wolfenstein data files, so the level files and all that sort of things. So he can't really use a lot of the GDScript and scene logic. He has to do everything in C#. It's quite impressive what he's trying to do. I think he's nuts. Sorry to say, but I am duly impressed with his work. It's but yeah, I do sometimes wonder if he hasn't made his life more difficult than it needs to be. But it's impressive. It's really cool, and can't wait until he has it to a place where he can start playing Wolfenstein. And this is the old Wolfenstein, right? The old original Wolfenstein ID did in the early 90s somewhere, using those game files. And then I know that there's another project, someone porting that, or has already ported that to VR, but he's doing it all in Godot with C#. It's an amazing project. Yeah, I'm looking forward to playing that once he gets it to a point where you can. But yeah, it's a crazy amount of work that he's doing. Hi, Ignacio. So yeah, I've talked about this in previous videos, so I don't want to spend too much time on this. As far as I'm concerned, the code of this project is open, which is also, you can see me writing it here. But I am currently not in a position to share the project as is, because I am building this into a full game, and it's laden with assets that I cannot share. So I haven't figured out yet how I am actually going to share the code in a way that it's usable, because either I would need to just put the source code somewhere and it won't run, it won't work because you don't have the assets, or I'm going to have to find some other way. I haven't decided on that yet. I'm open to suggestions of people. I've also been thinking about tying that into my my Patreon support, just because it's such a unique project that I'm doing here. But it is also one of the reasons that I want to do as much work as I can on stream, because you guys can follow along with the decision-making process, with the structure. And yeah, you can't really copy the code because you're looking at a video. But you can at least see how things are put together and replicate that. But yeah, once I find an acceptable way to publish this project without getting into trouble with the assets that are part of this game, and like I said before, the fact that I do want to turn this into a full game, that I who knows, a year or 2 years from now, when it's actually working, I might even release it. So there are some issues there on how, but it is it is definitely something that I do want to do in the long run, to make this stuff available. Like I said in my previous videos, I consider none of this code proprietary or anything like that. I am putting this on stream. Anybody who sees code and wants to copy it, wants to use it, even if they have to type it in themselves, copying it from a video, it's all there for anybody to use. Again, also a lot of this stuff obviously has been covered. All the state machine that I'm working on right now is new, but a lot of this stuff has been covered in tutorials. And possibly, if this state machine, once it works and it has enough parts, I might actually do a tutorial series about it. Don't know yet, because there are some really good existing ones from other YouTubers who have already done some really good state machine tutorials. So I'm not quite sure if I'm really adding anything there, but it's definitely worth something that I would consider doing. And I am looking forward to seeing your space shooter. I love space shooters, even 2D ones. So obviously, if you are going to doing it or changing it into 3D, then I can only recommend it. I love the added freedom that you have when you do stuff in 3D, but 2D is just as cool. Anyway, so back to this. How are we doing on time? We're only at an hour in, so we got plenty of time left. So we've got our moving forward. That one's easy. We just gun the throttle. The steering is going to be the tricky part. So obviously, we can only do this if we actually have a follow path to follow. So when we look at our path, this is really just a container object, and it contains a curve. So that's the thing that we just set up over here. No, not over here. Over here is we set up our curve, and we basically have that curve there. Now there is a big problem with our curve, and that is that the curve has got no idea that it's contained within a path. So when we grab the curve, we're going to get that curve in local space of our path node. So we have to do some conversions back and forwards there, and that's where it starts getting really, really funky. So let's start with actually grabbing our curve so that we have some easy access to it. There we go. Let's actually cast that, because that's a curve 3D. And let's also go and open our curve 3D in here so we can have a look at what it does. And actually, before we go there, let's go back to this guy and look at our curve 3D here. All right. The variables that are interesting to us is, first of all, the up vector. That's something that we're actually not doing anything with. And unfortunately also something that we can't influence when you set up the curve. So right now, I took special care of making our curve flat in space and not going up and down, which of course is something that you do want to do. But the up vector, if you're actually using the follow curve, there's not a note, by the way. And I'm not using that on purpose. It's called path follow. But I wanted to quickly name it. So you have a path follow here. And I believe that you need to, does it say it? You need to make this a child. Yeah, so if I make that a child here, follow. This guy actually has some logic that you can increase the offset. And it will follow our curve exactly. And if you then make your object a child, your child will move along that path exactly. But we want to have a more dynamic way of working, because we want the ship to steer. We want the ship to react when it gets knocked off course. You know, when it gets hit by a missile, you'll eventually go and make sure that that works nicer. So we can't use the path follow node because we don't want it to follow the path exactly. But the nice thing about that is, especially when your curve goes up and down, if you're, imagine your plane banking around a curve to follow it. That is something that the path follow will do if your curve has got an up vector built in. So that will slant the up vector to make your ship move. Now, in our case, we don't care about that because we're only interested in a point towards which we're going to steer. So we don't actually care about that. I'm just going to leave it the way that it is because we're not using it. But the thing that we are interested in is this bake interval. And this is the one that we need to be a little bit careful with, especially on the scales that we're working here. So bake interval tells us how far apart our curve is going to have values in between. Now, I'm not sure if 0.2 is a factor here. No, it's not doing anything over there, so I don't think it's influencing our visualization of our curve. Basically, we just have defined that point and that point. And when the curve gets instantiated, it will actually go and create all the in-between points around that curve, because that curve logic to figure out that curve is actually quite expensive. So in order to optimize this, Godot will calculate all the in-between points. And as we're moving along our curve, we're actually interpolating between those interval points. Now, in our case, and I wish that this thing actually showed how far it was. So I'm just going to have a temporary spatial here. Actually, let's create that as a sub from this guy so that we can start here. And we're going to go and put a transform. If we move that one to where that point was over here, why is that Z so high? Is it really that far? It is. Okay. So we've moved almost 1,000 units from here to here. Well, if I understand our bake interval correctly, and we're going to create a point every 0.2 meters, that's 20,000 points just for this section. That's overdoing it a little bit. So for a very fine small track, because remember, normally you're working on a much smaller scale. Let's say that you put a path around a racetrack. racetrack isn't going to be this big. So you might want to use a low bake interval like this. But we're going to make that a bit higher. We're going to set that to 5. Maybe even 10. So between here and here, we're probably already going to have about 100 points. So we might still be overdoing it for the size of our curve. It's a shame that it doesn't actually allow us to visualize that a bit better. So we probably can even up this even more, but that's fine. So the moment that we use our curve for the very first time after starting our game, it is going to calculate all the points around that curve, and it's going to cache that. And then it's going to use that. It's called, baking, caching. Depends on which way you look at it. It's kind of the same thing. But yeah, it does that bake one time. It calculates all those points around the curve, and then we can use those baked values and interpolate between those. So when we look at our curve, you'll see that there's a normal interpolate function here, which is not going to use our baked things. It's actually going to do all the expensive calculations to figure out where we are. But our interpolated baked allows us to get a point very quickly because it's going to be using those values. Now it's using an offset here, and if I'm correct, that is the distance along the curve that we are. So that's the other reason why baking is important, because we need to figure out what the total length of our curve is. That's this guy over here. I just want to highlight it. I don't want to jump around. I just wanted to highlight that one. Obviously, it clicks a little bit too quickly. But it allows us to know the length of our total curve, which is going to be pretty big. That's fine. So we can also get all those baked points and stuff like that. Obviously, that's not something that we want to do. The ones that we want to work with is these guys. Get closest offset and get closest point to a 3D vector. But the important thing here is that we're going to get our closest offset to point, but the point needs to be in our local space. Nice little warning here. Because again, our curve 3D has got no idea of where we are in space. It doesn't actually get the location of our path node from anywhere. So we're going to have to take our location of our ship, translate it into local space of our path, then figure out what the closest offset is. Then from that closest, actually, I need to point this out over here. It's better. So let's say that our ship is now over here. It's somewhat off course because it might have followed us around for a little bit. So we're going to figure out what the closest point is. So it's going to give us that point over there. Now we don't care about the point. We care about the offset. So the offset from our start to here is going to be our offset over here. But now what we want to do is we don't actually want to fly to that point, because eventually we should be on that point. We want to go somewhere slightly forward of that point. So we're going to increase that offset and then figure out what the offset is at that point. And that's what we're going to use as our target to steer towards. All right, let's catch up on chat. Is there anything else you code beside games? Yeah, for work, I actually build accounting software. It's very far removed from game development. So yeah, I do that sort of stuff, but obviously I don't do that with Godot. That's we do a lot with Vue and Rust and a little-known environment called Omnis. That's a language that I've been working with for years now, but it's all business software type stuff. And for mobile development, I do a lot of Vue and Rust and stuff like that. So it's fun in its own way. But yeah, not game related. Game related for me has been something that I've been doing as a hobby for well over 25 years. So and with Godot for the last 3-4 years now, I guess. Something like that. Yeah, PigDev has got some really, really good tutorials. You know, GD Quest, Kids Can Code, Heartbeast. There's so many good Godot YouTube channels, all worth checking out. Game Endeavor, who is on the chat somewhere, if he's still around tonight, who does some really, really cool tutorials as well, and lots and lots of others. There's a page in the Godot docs that lists a whole bunch of them. So go and find that. It's a good resource. I definitely want to check out your project, Ignacio. So I don't think you can post links in the chat. So just email it to mux213@gmail.com, and I'll go and check it out. Two Love Bees. Hello, Cheesiness Hive Time developer here. Now, I know cheesiness from my demo days. I don't know if that has got anything to do with your cheesiness. I used to be in a demo group, a joke group that eventually, at some point in time, called itself Cheese, and we did a whole bunch of diss magazines. That was actually a fun time. But that's probably not something that you're referring to here. As far as rules in accounting, yeah, there are rules. Accountants are weird. Tax is even weirder. I don't know. I very often have the feeling that a lot of the tax laws that we deal with are designed to keep accountants employed instead of designed to make sense. I definitely think that the people who do your taxes are better off than you, as in hopefully getting some tax back during the year. That reminds me, I actually still need to do my taxes this year. I haven't gotten around to it. And yes, I fully agree with you. When it comes to games, you are always trying out new things. I guess with business software, you are to an extent. But yeah, the challenge is very different. And look at something that we're doing tonight. We're trying to figure out an AI, a very simple, straightforward AI. Never done it before, so it's going to be very interesting to see. Well, never done it before. I've done a few experiments before this, but it's not my, it's not my expertise. So I'm learning as we go. Anyway, let's put into practice what we've just been talking about. So we need to go, and I'm just going to call that target vector 3D, and we're going to start with getting our global transform dot origin. Whoops. Actually, I want to go and copy that into a separate NPC position, because we're going to need this later on as well. And I'm actually going to go and move that one over here. And I also want to put this one here. Now in this case, it kind of automatically does a typecast, so this is a bit overdone. But let's just put it in. There we go. What is that? A small d? There's no D in there. Okay. I got confused by the 3D and curve. It's actually good. Yeah, no, it's not giving me an error on that. So I want to have those so that we always have them available, because we're going to be using those a few more times. So we're going to start with putting, actually, then we don't need to do that. Instead, we'll calculate that in a minute. So we actually first need to start with calculating our offset. I'm going to get that from our curve, and we're going to get our closest offset to our, okay, that's why I wanted to do that first. So let's put a target over here, and we are going to do this. So BC position. Okay. Sorry, we do need that, but I want my auto completion to keep working. So, no, global transfer. So we get our, and let's zoom this thing in. I always forget to do that. So we're going to get our global transform of our path. And now we're going to call the inverse x form. That's going to transfer a coordinate into local space. And we're going to give our NPC's position there. So this is going to take the transform of our path that has our curve. It's going to take our position of our ship, and it's going to turn that position into a local position, local to our path. And that allows us to use this in our get closest offset. Because remember, in our help, it said of get closest offset that we had to get our point into local space. So now that we have our closest offset, we know the closest point on our curve as a expression of the distance from the start of our curve. And now we can move it forward somewhat. So we're going to go and put a variable there so that we can control that a bit and figure that out a little bit. All right. Cool. That's okay. Yeah, it's a different world, isn't it? Accounting and billing and stuff like that. I worked for 10 years in Holland on telecom billing, which is very high volume, very interesting, very different challenges there. Look fondly back on that time, to be honest. I miss it from time to time. Richie, thank you so much for the series. Well, yeah, glad that you're enjoying it. Have I created a laser beam? We have a laser weapon. Once we start testing this, I'll fire it a few times. But they work more like bullets. They're not really a laser beam as in, something that directly targets things. They're more like the sort of lasers that you get in like Star Wars type of thing. Right now, they're very simple little box. I haven't been spending any time on making it actually look good. I've purely been spending time on getting the logic right. The getting it to look good is definitely something that is high on my list of things to start working on. Because obviously, we want to have some cool effects when we shoot our things. I'm also very much looking forward to finally building a proper railgun. But I want to wait with that until we actually have a proper ship that actually has some proper gun models on it. The other thing is tracking, which I really want to get into, where I want to start using the direction that you're looking at to guide to some extent what you're shooting. So that you actually have guns that are on a pivot. So I'll have a look at how that goes eventually. So yeah, lasers in the sense of directly pointing to a target and just being one big laser beam, no, but lasers in as a projectile laser, as a Star Wars type game. We have those. They just don't look very good yet. They work fine. Just need to work a bit more on making them look cool. Alrighty, so we got our closest offset right now. So now we need to go and have a look at using that offset to actually get our point. So we're going to be using our interpolated baked function. That's going to give us our vector there. Alrighty, so our no, actually, I'm going to just update our target for that because we have that one already. And we're going to do here our curve dots interpolated baked. We're going to use our offset plus our look forward value. I don't know if it automatically wraps around, so we're going to make it wrap around. Fmot curve gets baked length. That should make sure that once we extend over our baked length, we go back to the beginning. So that makes sure that we go nicely round and round and round. We're not going to do cubic. That's way too overdone. So now we have our target 100 meters forward from our closest point, which we now want to go and put into global space again. So for that, we're going to go and use our follow path again and our global transform of our follow path. And this time we call xform, and now we have our target point. Now the last thing that I want to do, and again, because we're using global space, even though our follow path is a node 2D, we can go and abuse that fact and just create a, I'm just going to call that debug. And we're going to make that a, where are you? Sphere. Boom. There we go. How big is this thing? We'll keep it nice and big because I really want it to be visible. So what we're simply going to be doing is we are going to go and take our debug global transform dot origin is target. So we're going to position that ball where we're aiming, basically, so that we have a visual indicator where this guy is going to. What I'm also actually going to do, just for testing, is I'm going to give us very little thrust. I'm going to make this guy fly really, really slow. It's not steering yet, but I do want to have a quick look and see if we can see what that ball is doing. Let's hope that we didn't make any typos and this breaks out. Let's go and fly off. So it's our leftmost enemy that's going to be doing something. Let's have a look at this. What you're doing. Here it is. And we can see it's not moving fast because that thrust is very low. We can see our little ball there. And I probably should have made it unshaded so it's easy to see, because now we see that it keeps blinking out into shadow because of our asteroids. So that is basically where we're targeting at. Okay, cool. I'm going to make our thrust 0.01. Hopefully that's going to give it enough of a push that it's going to move. Now right now, if we would actually let it fly, our ship is facing that way, so it will stay on course until it gets over here, and then it will fly away from our. That gives us, if it moves, that gives us enough of a bit of space. Alrighty, there we go. Let's see if this. Oh, that's the other thing I still need to work on. My shield hits the runway. All right. So, I'm guessing that our thrust is way, 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 way too little. Really? I am really surprised by that. No, that's a bumper seat. I want to look here. So our current throttle is going to be between 0 and 1 depending on our input. Is that true? Sorry guys, I just want to do a little bit of looking around. Where's my... Oh, it's because I'm zoomed in, that's why I can't see it. Yeah, so our thrust is going to be between 0 and 1. So that should be between 0 and 1. We have a thrust vector, which is only that. So we're going full throttle, and we're going pretty fast with our main character. Okay, so oops. So why aren't we moving forward? I want to see my ship fly. Yeah, so oh, almost knocking things down. The steering is all done by that guy. So obviously, when we have our headset, you know, I can look around. So I can put my headset on and I can look around. But obviously, the way that the direction that you're looking in does not influence what we're doing. Now, this is interesting. My enemy ships have all flown off. There's my little shooting lasers. Where are my enemies have gone on? So now we're getting them more than enough thrust that they are long. Oh, they're all over there. Look at that. So why are all four of them flying? That's the other question. And I think I know why. Because they're probably all sharing the same node. Is that so? Let's have a look. Start scene. 3D. Boom. 1 by 1. Let's get my follow path. These don't have follow paths. Okay. They all have the default state. That is fine. So does that mean that it's sharing this resource? Would it? That would be weird. Ah! Okay. So we've only made the first guy actually follow. But the other three still do get our logic here. So we're actually going to go and put all of this on the follow path, so that if we don't have a follow path, we're also not going to fly. So that should mean that only our first guy flies. Now the other thing is that our thrust meant that those things really flew off. Yeah, little hot dog lasers indeed. Like I said, I haven't made them look good yet. They're basically just squares. So now we can see that our one guy is flying off. But he's going way faster than I wanted to go. Maybe we didn't save our script when we put this to 1. Let's have a look. Because I want him to move really, really slowly. Oh, we hit our thing again. Alright, so he's now going. I think we need to make our little ball bigger too, so that it's easier to see where it is. But he's off. But we should eventually see that he is going to fly too far away from that curve. Because that ball is slowly starting to follow that curve. Now I think we made it to go too slow. Would it be nice if we actually had that curve visualized in space so we could see where it's going? Maybe we should quickly write something for that, just as a temporary thing. I think that's probably a good idea, because I want to go and visualize those things. All right. Let's do that here. Yeah, that's probably going to be a nice idea. Yeah, let's do that. This will probably ruin our frame rate. Oh, let's be honest. I'm expecting fully to get a detrimental effect on our frame rate for doing this. Anyway, let's go back to our follow path scene. The first thing that I want to do is I want to create spatial material on this guy. And I want to make that not transparent and shaded. Boom. So this is now going to be a pure white dot, which is exactly what we want. All right. So when we set our follow path here, if we have a follow path, for let's just create 1,000 of these guys. Thing is follow path curve dot gets. Does it really not do any of our autocompletion when that's a problem? Len is of course reserved. Pavlen. Get bake length. There we go. So here we want to do var position is follow path curve interpolate baked path length times I divided by that's. I hope that's not going to give us an integer problem. False. There we go. Is actually let's just do var new mesh is mesh instance dot new. So we're going to create a new mesh instance. New mesh instance dot mesh is going to become debug dot mesh. So we're going to give it the same mesh. Then we're going to do add child new mesh instance, and we're going to say dot global position dot no, not global position, global transform dot origin is follow path global transform dot xform position. So that should create, when we set up our follow path, that should create a mesh instance around our path every whatever distance, so that we get 1,000 of them. So we'll see what that looks like. So that should at least give us some visualization of our path in 3D space, so that we have a bit of an idea of what we're going to do. There we go. We should probably also have made our enemy ship move a little faster. And I think we probably need to, well, actually we can see pretty well how that little ball is moving along our sphere. But because our enemy ship is going too slow, we're not going to see when it stops, because we're still not following it, right? I just want to see if our position along the curve is indeed doing what we want it to do. Oh, dang it. I really need to make sure that the shield is off when when we exit our ship. This is the slightest bit of joystick input and we hit the runway. All right, so our enemy ship is going a bit faster. And he keeps going flying. Cool. There we go. But now we can see that he's slowly starting to move away from the curve because we're not following it. I just want to see what our... Well, this is where our ball should have had a different color, because we can't really see where our ball is. It's still moving there. We can still see it moving. But at some point, you know, we're going to fly in a way that it's not actually going to keep following it. All right, so let's actually start using this, because that's really what we're here for, right? Okay. Now I'm going to just make it turn into wherever that's pointing. So I'm not really going to worry about it wanting to reorient the ship or the craft in a way that it's nice and level with our path. We're not really going to worry about that right now. That is definitely an improvement that I want to do eventually. But for now, I'm not really going to be too worried about it. For now, I'm just going to steer it in the right direction. And this comes back down to the same thing that we were doing with our missiles, where we're taking our heading that we're going, and we're now going to take our direction towards our target, and we're going to try and make it steer into that direction. All right. Let's actually have a look at our missile logic, because we did all that work last week. And this is really going to be doing something very, very similar. All right. Let's blow that up a bit again. So the same thing, we're going towards a target. In this case, it's our enemy ship that we're going for. You know what? Let's go and copy that. What's our cutoff here? Oh yeah, okay. That's cool. So let's go and copy that over here and then alter this bit of code so it does something that we wanted to do. All right. So in this case, our target is already our position, which is cool. We need our position of our craft. So that's our NPC position. So that's going to be our heading. Then in this case, we got our NPC facing, oops, that we cross with our target. And we get our dot product. So again, if we have two vectors pointing away from each other, our cross product is either going to point upwards or downwards to get our vector pointing out of the plane created by our two vectors, and our dot is going to give our cosine of the angle between the two vectors, where we know whether we're going left way around or right way around, depending on whether our cross product points up or points down in that plane. So we can use that to know how much we need to rotate our ship. All right, so we're going to go and do our cutoff here as well. I'm actually going to do that slightly different. We're going to give it a cutoff value there. Yep. Oops. That's going to become an unready var, and that's going to be cos to rad cut off. And I actually need to do that in our missile script as well, so that we have a human readable angle here that we can set and fine tune our logic with, and we have the value that our logic wants to do there. All right. So that goes cross times delta, and we need our torque vector. And actually, I really should be adding our delta into here as well, but right now our delta is a fixed value because it's our physics process, but we really should be adding that in there as well. And we should be doing that on other places that we do similar things. So in our missile here, what we're using as a torque vector. Yeah, let's keep that the same. I think the torque factor needs to be bigger here, because we're dealing with a larger object that has more mass. Okie dokie. And that obviously needs to be called on our NPC. There we go. All right, I actually want to go and put delta in here as well, which now means that we need a much larger thrust force. Let's just start with 10 and see what that probably needs to go up quite a bit for our enemy ship to still have some power, because we're going on 1/90th right now, so it's still moving. I'm being a little bit careful getting out of our hangar before we move. But let's go and have a look. Oops, that was stupid. I didn't want to fire that missile. Although, yeah, it missed, because it's moving now. So we're now seeing that our enemy has found our curve, and it's starting to follow it. It's not going very fast. It's actually going quite slow. And it's not turning very fast as well, which is interesting. But it is turning. Let's give it a minute, see if it actually keeps following our... Well, it's back on there now. Alright, I want to make it go a bit faster, see if it keeps following it. So let's make it 3 times as powerful. And now I actually do want to put my headset on, because I want to see a little bit more clear where it's going. Alright. Let's see if it keeps following our path good enough. Now, interesting enough, it is quite a bit away from the path at the moment. So is it now going too fast that our turn impulse is just too weak? I think so. Again, like I said, it's a lot bigger than our missile. So I think it's going to have a lot more turn factor. Now, interestingly enough, let's actually have a look at our script here. Here we're using about 10, but am I using delta in here? I am using delta in here. So there's a good chance that this would actually be good enough. Alright. Let's have a look. Here we go. What is it doing now? Well, it's gotten nicely onto our curve. Let's see if it starts to turn and follow it. Yeah, it looks like it's trying its best to keep up. Let's see if we can knock this guy off course. Let's see what it does then. There we go, it knocked him off course. And it's trying to get back to the path. Let's see what it does. Well, it needs to correct now. And it's trying to get back onto... Alright. I don't think it can steer fast enough, so it's overshooting. That's going to be interesting, because it's about to do a bigger turn. Let's see if it can make that turn. I think our... It's trying its best. Yeah, it's not bad. I think one of the things that's going to be interesting is moving that target point further forward on our curve, depending on how fast we're flying, so that it knows that it needs to steer quicker. So it's corrected its course pretty well. See if we can move around here again. Come on, little guy. I think we're going to want to make it move a bit faster as well. But yeah, I think we're going to make our target sphere move more forward depending on how fast he's traveling. Alright, let's knock you off course again, buddy. Knock you off course a lot. So there's no damage when we push our ship away. Alright. Let's see what it does now. So yeah, it's trying to get back to the line, but then eventually it overshoots. Yeah, it's not bad. It only overshoots by a bit. Yeah, cool. So it doesn't reorient itself, and I'm happy with that for now. But it is following our path. So, not a bad start for just putting in some base values. I am going to up that a little bit. And the other thing that we're going to be doing, okay. Probably want to have a No, I'm going to leave that for now at a fixed value of 100. I'm actually quite happy about that. We might play around with that eventually a little bit more. I actually want to go a little faster too. So we're going to give that 50. And I think it's about time that we're going to start working on our wingmans. Okay. The other thing that I'm wondering about is should we... Yeah, I think we should. No, because we don't have our NPC to begin with. Okay. Let's go and create some wingman AI logic. Alrighty. So, in our start scene, we're going to start with telling our bomber number 2. That's going to be the wingman of bomber number 1. And we're going to give that the fact that it's also going to be following the path. So we're just going to run it just to see what happens. They're probably going to clash each other and see what happens with that. But that should become its default behavior when its wing leader gets destroyed. And that's something that we're going to be doing in a minute. So let's go and have a look. Oh, dang it. I'm going to hit that thing again. Ah! Okay, I really have to make sure that we've got our shield turned off when we're inside of our hangar. Okay. Now this is pretty surprising that they're actually following each other. And the reason that they're kind of following each other is because they are bumping into each other and they're pushing each other off the track. So that's fun. Okay, that's pretty neat actually. Okie doke. All right. Yeah. So again, I wanted to have our wingman follow the same path because when our wing leader gets destroyed, we want it to go back to that behavior. So in our bomber scene now, we're going to get a new no path. Actually, I think we're going to call that wingman 4. So we're going to tell it who it is a wingman for. All right. Now this is going to be a little bit more interesting because here we want it to follow our wingman. So instead of it following the path, it's going to follow whatever the location the wingman is. But we also want it to adjust its speed to match the wingman's speed. So here we're going to have to track a little bit more than we were tracking before. Okay, so that also means that we're going to need a new state. So we're going to do the same thing we did before. We're going to call it AI wingman. Now we're going to go ahead and save that. There we go. And we're going to go in there, and I'm going to use the same little trick I did before. Script, load states. We're going to load our base state, and then we're going to extend it. There we go. Boom. All right. Cool. So obviously it needs to know who it's a wingman for. Come on. Oh, what I'm doing. Wingman for you. Wingman for. There we go. Okay, so that's going to be pointing who it's a wingman for. And then we need a bunch of logic. So what I'm going to be doing here is I'm going to go and copy this, and we're going to copy that over there. And we're going to be implementing that. Now, one of the things that actually is interesting is some of these we're going to have to duplicate in these guys, in this guy. And I wonder if we want to repeat them every time, or if we want to actually record that information on. We'll copy them for now. Actually, I'll do that right away. But yeah, I think I'm going to do something that we can store this information on our plane and then share it with all the scripts so that we only set it up once and we have all the scripts use the same information. All right. So now in our bomber scripts, we can say over here, if wingman 4, and I want to zoom in again because you can't see anything. All right, so if we are wingman 4, the first thing that we want to do that's because we're in the wrong thing. There we go, save. There we go. Set wingman 4 get node wingman 4. Boom. So that's the first thing that we need to do, is communicate to our AI. This is the wingman that you're supposed to follow. Sweet. And then the second thing that we want to do is call change states. Why don't I actually get the auto completion for that? I don't know. We're going to do that. And we're going to set true. So remember, in the change states, let's go back to our AI. We had two properties. First, a new state that we want to give it, which is our wingman state, but also whether we wanted to push it. So now our wingman state is going to be on top of our it's going to be on top of our follow state. So that's going to disable our follow state, and we're now going to be doing our wingman state. All right, and our wingman state right now doesn't do anything. I'm actually going to make use of that to demonstrate how this works. But the other thing that we need to do is, and here I need to have a look at, so we have our die here. Yeah, that's over there. Okay, so one of the things that I want to do first is I want to define a new signal here. Died. So when a unit dies, when we destroy it, we want to go and emit a died signal. Not quite sure about that name. So we're going to go and emit our died signal so that we can subscribe to that and know when something dies. Okay. Now the other thing that we need, which we, no, actually we can, because we can do the change state. So the other thing that we need to do on our base state, and I should really have named that AI base state. I can probably still do that. I'll not risk that right now. Is we're going to create a signal here as well called change states, new states. What's that thing called? Push state. So we're going to create a signal on our state. Now, this is where I'm deviating from what, for instance, Nathan did. Nathan is actually returning from our handle physics process what new state we want, if we want one, and that means that we need to have some mapping. But we're going to be doing it through signals and hooking the signals up. And that's going to be some interesting little things that we need to make work. Now, in this case, we don't have to worry about it too much. And again, I might change this. I just want to see if that works properly. So in both cases here, I want to make sure that I want to go on Bumper. Why can I not see my existing functions there? Because I should be able to just call, oops, this one directly from there. Hold on. Does that now work? Well, let's just try it. A little surprised that it doesn't. Maybe because that's coming from a maybe because that is coming from an extended script that it doesn't actually allow us to do that way. It's gonna be interesting to see if that works. So in our follow man path, we now have our wingman. So what we can do now is connect died. No. What are my parameters? Signal, target. Ah, now I remember. So yep, that was died. On self. Ring leader died. There you go. Alright, funk. Wing leader died. Actually, we're gonna go and call this guy wing leader. Bank. I think that's actually a much better name. And that means we actually want to change that name in our auto script as well. Init. Change state. No. Yeah, false. Okay. So this will remove our top state off because we're not adding a new state in. We're not stacking. So let's see if that works. So obviously I also want to set the wing leader to null, that we don't remember who the wing leader is. So that should handle all of that. Sweet. All right. Cool. Alrighty. Why do I have set follow path here? I think I copied the wrong one, didn't I? That should have been handle physics. Sorry about that. Helps if you copy the right one. So, I also want to rename wing leader in our bomber script. So that's going to become wing leader. That's going to be wing leader. There we go. That means that we also need to change that up top. And then now in our start scene, obviously we have now lost that. So wing leader assign bomber 1. Okay. So that should mean that, seeing that we haven't actually implemented our physics process for this state, is our ship should stay where it is until we destroy its wing leader, in which case it should start following the path that we set out for it, provided I haven't made any mistakes. Hey Go-Guards, thank you for joining. Glad that you finally can make one. It is a bit of a challenge with time zones and everything like that. I'm going to use my headset again. Oh, look at that. So, of course, we renamed that, and we forgot to also rename the call. There we go. All right, that's what you get when you decide on new names last minute. Alrighty. So we can now see that our wingman is no longer following because we haven't got any follow code yet. Let's go and kill this guy. Oh, our sounds aren't working properly. Our missiles definitely have a lot more problems following this guy. Alright, so this guy's dead. And our wingman is not changing its behavior. Alrighty. Well, mission failed. Mission failed. Okay. Alrighty. So, oh, I know what we forgot. We are overruling die here to turn our engines off. But obviously, we want to make sure that we call the original die function so that our signal actually gets emitted. That might be handy. That might be very handy. All right. So our missile is missing because it's overshooting. And that's because it's targeting our current position of our enemy ship. And it's not taking into account that our enemy ship is moving. Alright, we crashed. We crashed. Boom. Non-existent function die. Okay. That's underscore die. Getting close. We're not going to use our missiles because obviously I need to make sure that our missiles start tracking the speed of our enemies. I might have a look at that later on. I am a horrible shot. Okay. He's down. Let's go and have a look. Did that do anything? No, it did not. Alright. So we now know that our die is being called, which should in theory mean that our signal is being called. So what are we missing? So we assign that to that. That's good. That means that we set wing leader here. Then here, if we have a wing leader, we're connecting died to wing leader died, which should mean that this guy gets done, which means that our change state is being called. So let's start with putting a print here and saying a wing leader died and see if that indeed gets called. All right. Not, yeah, I'm gonna put this on. It's easier to target that way. All right. Wow. I actually hit him. That's the other thing that we need to do is when we hit our enemy ship, we actually should get some visual indications that we're hitting him. There we go. Okay, that guy is dead. All right. Did we get anything? We actually got it called twice. That's interesting. All right, so one of the things that I want to do here we're just going to go and call disconnect here. Okay. That's why. Okay. So, the missing ingredient is that's okay. So we're coming in here and we're checking if we have a current state, which is currently our wing commander state. And we're calling exit on our wing commander state. Now, one of the things that I also want to do there, which I suddenly realized, this is not our problem, but I do want to do this just in case. So if we ever exit our wing commander state, there we go. Is that so? Do we want that? No, actually, that's fine. I don't care about that, actually. No, I don't care about that. It's only when he dies, then we want to remove that. So that's, I'm thinking of the wrong thing there. Anyway, so we're exiting our wing commander state, removing our wing commander state from our stack. And what we're now doing is we're saying, if we have a new state, we're assigning that and we're running that. But in this case, we're setting through null because we don't have a new state. We want it to return to the previous state. So what we're actually going to do is we're going to change this bit of code. move that over there, and say, oops, new state. If we have a new state, we're going to be doing this. But if we didn't get a new state, we're going to take the current top state from the stack. So we're going to do if state stack dot, is that a length? Do we have a length on there, or size? I think it's size. So if we still have a size, then we're going to do this, and else we're going to say current state is null. So if we don't have anything on our state stack, which never happen, we should always have at least one base state, one default state there. If we don't have it, then we're just going to set it to null. So in this case, we're going to say current state is, now do we have a easy access to that? Do we just have a get the top? Because we have pop back, but that will actually remove it. Do we just have a back? We do, back. Returns the last elements, perfect. So this is going to be state stack back. And that should return us back to the state that we had before. All right, the other thing that I want to do here, let's see if it works. Let's see what it does. Pew, pew, pew. Yeah, it doesn't make a pew pew sound. But it broke my locking sound, which is interesting. So I wonder what I did there. Oh, all the way on top of the ship. All right. I'm missing most of my shots this time. Ooh, even missed a missile. That should have hit. That looked like it was clipping it. We need a health bar for this guy. There we go. He's gone. Alright. Okay. Look at that. Our wingman is now following our path. Sweet. So the moment that our winged leader got destroyed, our wingman suddenly decided, yeah, maybe I should go and follow my... Well, I'm going to kill you too. Try to anyway. Yay. Okay. Cool. We're getting somewhere. Alright. So now we actually need to make our wingman follow our winged leader. How are we on time? Oh, it's almost 12. Oh. I wonder if we're going to get enough time to actually make our enemies attack us. No. Let's at least see if we can complete our wingman logic. So, all right. So one of the things that we want to do okay, let me think. Because we want to have it follow at a certain offset. All right. Okay, how are we going to make it do that? Hold on. 3D. Look. So it's moving forward on the blue line. All right. So we're gonna add a helper spatial in. Oh, we're also creating another little debug in here. Because again, we do want to be able to visualize what we're doing. Obviously, these debug things will remove eventually. But for now, we do want to allow us to visualize what it is that we're doing. So I'm going to make this unshaded again. Let's go and give this guy another color so that it just sort of stands apart from the other ones. All right. So that will allow us to visualize where we're trying to fly to. Yeah, we're getting close to it actually becoming a workable game. As we're really starting to get all the ingredients together. Still a lot more to do, but as far as, you know, just being able to fly around and shoot things, and hopefully eventually get things shooting at us. Yeah. Sure. All right. Oh, I went too fast. So we're going to move this guy a bit back, and we're going to put him to the left. Okay, how far did we do that? How big is our bomber? What is my shield? 18. So we're 18 that way. All right. So I want this one to be 20. Let's put it there. So the reason I'm putting this is that's where I want our wingman to try and stay. Now, when he's actually there, then obviously, you know, our target, we're going to actually adjust to there and then somewhat forward. And that's what he's going to try and fly towards. The other thing that we need to do is we need him to adjust his speed depending on whether he is in front of this point or behind this point. And obviously, if he's behind this point, he wants to speed up. If he's in front of this point, we are going to make him slow down. And that's how we're going to make sure that he's going to try and stay close to our wing leader. So let's first see if we can make him follow our wing leader, because right now, of course, our wing leader is going to fly away pretty quickly. Now we'll see what it does. I think it's going to hold position relatively well, but it's not going to be it might get in front of the wing leader and then start doing weird things, basically. So, all right. So we're going to be using that spatial as a helper. Target. We're actually going to go and rename that to target helper. Now remember, this is now a thing that is related to this, which is a node, which means that we now have this always in global space 20 minus 20. So we're going to have to do something a little funky with it. It's just to help us position it, and you know, at some point we might even make that a value that we can control more easily. So what we need to do here is we're going to go and again target. We're going to create a target position, and in this case we're going to say wing leader global position global transform dot xform, and our target helper dot transform dot origin. There we go. So our target helper transfer origin gives us that point, the location of our target helper, but in, well, local space to nothing. We're going to put that into the global transform of our wing leader, and that gives us an offset from our wing leader to where that little dot is. All right, cool. All right. Now we're going to adjust that target in order for us to create our heading, to do our heading logic. And that we're going to do by taking our target, and I need to think. Yeah, I do that on our wing leader's heading. So we're going to move that forward to be somewhat forward of our wing leader, because that's what we're doing. Now I'm making it a new variable because I still want to have my target variable to figure out whether we are going to be in front or behind our target variable. Yeah, we're going to figure that one out. Okay. All right. Actually, no, I don't care about that. Okay, hold on. Just speed. Just heading. We're going to do it slightly different for our speed in a minute. That also means we can copy a few things from here, because obviously we want to go and do a bunch of logic that we're doing there. So, here we go. I am going to go and copy actually all of this, because our logic is going to be very similar. So, we're going to reuse a lot of that. All right. So, for now, we're just going to apply our speed, but eventually we're going to go and turn it on and off depending on whether we're in front or not. So, we don't care about our target. We don't care about our that. We don't care about that. We don't care about that. So, there we go. All right. So now what we just need to do is we take our targets and we're going to add our wing leader global transform dot basis.z. So that's the heading of our wing leader. There we go. But we want to give that, we're just going to use our look forward. We still have our look forward thing. Cool. Times look forward. Can I actually just do this? I think I can. I like that better as a notation. Let's see if it allows that. All right. So it still wants that cutoff thing. So we do have a cutoff angle. So all that we need to do is copy this one. There we go. And that should apply our impulse. Cool. All right, so this should already make it follow, but if it ever gets ahead, a little bit too much, we're probably going to get some funky effects. So let's actually see if our wingman is able to sort of keep up with our friend. There we go. So they are nicely flying in unison. There we go. So we can see our white dot is what our wing leader is trying to follow. And we can see our green dot as what our wingman is trying to follow. All right. So our wingman is trying to follow our wing leader, and our wing leader is trying to follow our curve. Well, let's see what happens if I give my wing leader a nudge. Dun, you are off course, buddy. Well, our wingman still nicely tries and follows our wing leader. Now here things get interesting, because now that he is a little bit too far off, he's having a lot more trouble getting back to where he needs to be. Now obviously the other problem that our wingman has is that he's not allowed to go faster than our wing leader. So he's not able to catch up to the guy. I can also see that now that we've actually increased the speed of our wing leader, he's having a lot more problems getting back to that line. All right, cool. So we're going to tweak our values a little bit more, because we put our, we define our turn speed when we still had our thrust force at, I think, 20 or 30. So we never increased that one. So we're going to do two things. One is we're going to increase that one. Actually, I want to increase that by quite a lot. We're going to make it actually turn quite rigidly. All right. All right. There we go. Let's actually make this one be able to turn as well. The other thing that I'm going to do is I'm going to allow the wingman to fly faster than the wing leader. So the wing leader has a speed. We're not going to make him go full throttle. We're going to make him go a little bit slower than its maximum speed. And that means that our wingman should be allowed to go faster. Now our wingman is going to go and overshoot, which is going to be funny. But I need to do that on purpose. First of all, we need to allow him to be able to catch up. But that also allows us to cut the thrust when he gets in front of where it is that he wants to be. So that's a bit of logic that we don't have yet. But I just want to see what it does with that. Because I think right now it's going to overfly him and overtake him. And then it's going to try and turn. There you go. It's flying around. And he's going to try and take up position again. You can see that it has a lot more power to steer right now. He's going to try and catch up again. And then he's going to go and overtake again. Oh, he hit him. He gave him a knock. So I think we also let him be too close to his wing leader. They are now knocking each other, of course. That's funny. All right. Cool. All right. So there's two things that I want to do. The first thing is not that guy. Where's my man here? No, not you. The first thing is I actually want to move him a little bit more off to the side so that he doesn't try and knock the wing leader all the time. Maybe also a little bit more back. There we go. But the other thing that we're going to be doing is we're going to only apply our impulse if we are too far behind. Once we catch up, we're going to cut our engine. I'm not going to visualize that. We're just going to go and cut our engine. Maybe you should visualize that actually. Let's actually do that. Let's have some fun with that so that we can actually see what it's doing. All right. So the first thing that we need to do is we're now going to get our NPC's location in the local space of our wing leader. So we're going to take our wing leader, global transform. We're going to take our inverse, and we're going to go and take our NPC position. So now we have the local position of our wingman in relation to its wing leader. And now we just need to see whether he's not too far back. So all we need to do here is if NPC local dot z, because we're checking our z value. Now the other thing that we quickly need to check, our z is negative. So if it is smaller than negative 30, then we're too far behind. So in this case, if we are smaller than, of course we're going to use our target helper, z. So if we're far enough behind, then we're going to apply our impulse. We're going to speed up. But if we're in the right position, we're not going to do anything. Now to visualize that, oh, we can't do that here because we actually don't have access to our engines. Yeah, and we're just going to do that. Let's just see what happens. Let's see if it now stays behind. Let's just see what happens. Let's see if they nicely follow each other now. I see blackness. What is it doing? Transform. Ah. Origin. Well, the wingman or the wing leader was oscillating because the wingman kept nudging him. So now we can see that the wingman caught up, and you can see that he's actually speeding up and he's slowing down, speeding up, slowing down, because we let him catch up. So now we should be seeing that our wing leader is nicely following. Now let's see if we knock him off course, because now we've given him more power to steer. Oh, and we knocked our wingman. Oh, he got on course pretty quickly this time. So we gave him a lot more power to steer, which is cool. All right, let's see what happens when we knock our wingman off course. Oh, this is hard to follow. Hello, I want to knock you. Come on, give me. There we go. Ah, I can't really knock him off course. That's a shame. All right, let's shoot him off course. No, he corrects himself way too quickly. He's pretty good at course correcting. There we go. But he's oscillating a bit now. He's having a bit more trouble trying to get back into line. Okay, let's see what happens if I go and kill this guy. Alright, now he's going to go back onto that. There we go. So yeah, there is a bit of oscillation in there. Because it keeps overcorrecting. So yeah, that's definitely something that I need to have a look at if I can improve that. The other thing, of course, is, you know, we're not letting it bank or anything like that. But hey, for 3 hours work, not too bad. Okay, so obviously our path disappeared as well. That is because our paths were, or our path follow AI were childs of both of those ships, so they disappear with it. I actually want to go and take that logic out anyway. So let's go and get rid of this, because that was nice to have. I do want our debugs in there for now, because I want to see what it does, because I want to play around some more with that. But all in all, it's following. Our wingman is following our wing leader, depending on our offset. Our wing leader is following the path that we set for it. It doesn't do anything yet for deviating, because of course the next step is that they're going to try and figure out, you know, whether they see an enemy, well, friendly for us, but from their perspective, an enemy, so that, you know, the moment that an enemy becomes in range, we obviously change the state then to, you know, AI chase enemy or shoot enemy or whatever, and we suddenly start changing our logic there, and, you know, figuring out in what case it does things. And here a big question is, do we let the wingman always follow the wing leader, or does it suddenly start chasing you separately from the wing leader? We will see. Those are all things to think of. Let's see how chat's doing. Yeah, the cockpit right now is a fighter. It's a nice little plane. There we go. That I bought off of CG Trader. So this is modeled by someone calling himself CG Pitbull, and he makes some amazing fighter planes. But it is a stand-in. I am planning to. Well, I'm already talking to a friend of mine who is interested in modeling some planes for our game and cockpits for our game, and we'll do something that's more akin to what we're trying to accomplish here in VR. But for now, as a stand-in model, these are beautiful planes. I really like his work. So look him up on. He's on Sketchfab. He's on CG Trader. CG Pitbull. He's got some amazing work. Yeah, it would have left the green sphere behind, because obviously the moment that we destroyed the wing leader, we now stopped having our wingman AI be active. It now went back to path follow, but we're not doing anything to remove the green dot. That green dot won't be removed until our wingman actually dies, and that scene is destroyed. But again, the green dot is just for us to help to see whether our logic is working the way that it should. So yeah. So obviously there's a lot of room for improvement in both the steering and the speed. So one of the things that we could start doing here is, the closer we are to that location, the more we variate how much power we're giving to the engines to try and to try and match that up with the wing leader's power instead of just cutting the engines completely, because now we speed past that point and then we slow down, drop behind the point, speed back up, drop back down, speed back up. So obviously that is something that's there. The other thing that's really important is that our wing leader now flies off and our wingman decides a little later to catch up. So those are all the sorts of things where we have some room for improvement in what we're doing here. I think that last one actually we can solve by making sure that their positioning is better, because of course they're now in line of each other. So what we really need to do is move that guy already back from, so that that it more quickly, because now this guy needs to speed ahead before he suddenly decides that he's fallen behind far enough and starts catching up. But then he's already got some speed while he's still standing still. Right now, the moment that he starts moving, because we've moved him back a little bit, he will start following pretty quickly as well. So they should start off a bit better with that. And we should probably do the same with these guys. Now, the question that I have with these guys is, should they be following the same path, or should we create a separate path for these guys, or shall we just leave these guys hanging around in space here? We will see. So yeah, those are things to start looking into. So obviously there's room for improvement in our wingman logic, but I think the biggest thing, and this is also for our missiles, is that our rotation logic, this logic over here, is too simplistic. So we don't actually have our dot in here either. Not actually because of a cutoff that this one is actually not. That might be one of the reasons why it's oscillating more. But yeah, I am. I'm not sure if it's smart that it's. It's working this way. So yeah, yeah, I need to play around with that it doesn't oscillate much. But the other thing is that one of the things that we haven't gotten here is the reorientation of the craft. So when we look at our wingman, one of the things that we want to do is we want to look at the up vector of our wing leader and make sure that our wingman tries to bank so that it matches the same up vector as our leader. The other thing is right now we are floating around the y-axis, which is possible in space because we don't have drag. We're not turning based on drag. We're turning based on adjustment things, thrusters. But the more arcadey feel would be that, you know, as our wing leader starts to turn, we actually would like it to bank into that turn. So, and the moment that starts going straight, we would want to level off again. Of course, there is no up and down in space, but we would, you know, we would assume an up or down at that point in time, and that's possibly where the up vector in our bait curve might come in handy to do that reorientation. So I don't know yet. Still need to play around that. But the basic logic is really, you know, it's close to how we want this to work. You know, we've got a follow path AI where the ship tries to reorientate itself towards a path and try and follow that path around. We've got a wingman logic where it tries to stay on the wing of the wing leader. The next step, I think, you know, yes, there's a lot of room for improvement here, but I think the next step here is to start looking at it going for our friendly fighter when we get too close to it. All right, let's have a look at chat. Often feel sleepy when coding. I'm way too awake when I start coding. Everybody's different. What strokes are in now though? Yeah, exactly. You know, it's getting all the skeleton work done to get all the basic logic in there. You know, it's like the missile right now. The missile was working perfectly when our enemies were standing still. Now our enemies are moving, so we need to start figuring out, okay, how fast are our enemies moving, and adjust the target that the missile is going for slightly forward of the target that is flying towards, to try and, you know, be where the target is going to be, and that's going to be based on the speed and direction of flight of the target, but also the distance of the missile to the target, so that it tries to figure out to, you know, head towards where the target is going to be. So those are improvements on the missile logic that we need to do. On the AI logic, we need to do banking. We need to get that oscillation under control, make the impulse better. But all the basic elements are there. All the basic logic, the basic approach is there on switching between the logic that it has. Switching on, you know, my wing leader gets destroyed, the wingman now takes over, tries to do its own thing, etc., etc. So I'm not targeting this at any specific platform, although I am currently only interested in desktop, simply because I don't really want to worry about the performance from a rendering perspective. I did go for the Glass 2 driver instead of the Glass 3 driver for space. Glass 2 is more than good enough. Potentially, that might mean that if I get the right assets in here, who knows, this might run on a Quest. I have no idea. I'm currently, and that's also to answer Island Lian's question, yeah, that's an index. But this is all being built with OpenVR. I'm looking into OpenXR right now. There's a OpenXR driver for Godot that currently only works on Linux. I've been working on getting that to work for Windows, but unfortunately, time constraints have meant that I haven't been able to put the time into it yet to actually do the final steps to make it work. But yeah, this will likely be changed over from OpenVR to OpenXR once that is at a point that I can do it. In which case it would, you know, OpenVR already supports all the headsets. So I've got a Rift S up there, so I'm going to eventually be testing this with the Rift S. Also going to be testing it on my other machine to see, you know, this is a pretty beefy laptop. So obviously, and again, that's down the line, right? One of the most important things to realize is we haven't done any sort of optimizing here. I've said this before in previous streams. When we're inside of the carrier, our frame rate drops 50 frames per second right now, which is dismal. I know exactly why. It's because of the way that the carrier is put together. It's a single model, high poly. It's a very inefficient approach. We can get that frame rate back up to 90 by slicing that model into its components, so that the engine can actually start filtering out what it doesn't have to render, and all of a sudden things will become much more performant. But because I've got other plans, it's only a stand-in model for now. I'm not worried about those things right now. A couple of months down the line, when all the gameplay logic is in there and we start looking at actually putting the proper assets in, and we start looking at creating assets for this game, keeping our render budgets in check, who knows? We'll see. You know, and I would love to see it running on a Quest. Who knows? Possibly with even lower poly models at that point in time. We will see. So yeah, those are all things that will come eventually. For now, I am purely interested in getting a logic in there, just getting our game up and running. And you know, I'm running it on the index because I've got my index connected to this machine all the time, so it's just out of convenience. Plus, it's a really nice headset. I love it. It's yeah. I like the Rift S more for development. I've said this before. The one thing, can I pick it up easily? Something's falling down. Oh, why are my cables all tangled? There we go. Ugh. Okay. Here's my Rift S. And one of the things, it's actually good that I brought it down because I really should set up this computer to also handle, also be set up for the Rift S. But one of the things that I love about this thing is the fact that it's got the halo design. So, why is that? Oh, my daughter's used it last, so it's all set on its smallest layout. But yeah, this is the thing, right? During my stream, you've seen me take the index on and off probably about 100 times. And because it's like a ski mouse design, it's not as comfortable to continuously take on and off as this thing is. Because this thing with this halo, if it didn't keep doing that, you know, it's just so much easier to take on and off because it's not pressing into your face. So yeah, that's something that I really like about the Rift S. The Rift S halo design, and same with the PSVR, which is the first headset that I've got. The PSVR is so comfortable as a result. And when you're developing, I think that's really important. Because like I said, you're constantly taking it off. You're doing stuff, you press run, you wear it for a minute, and then you take it off again. So every time that you sort of clamp this to your face, and you know, I actually had luck this time because 9 out of 10 times my glasses get stuck in this thing. It's not the most comfortable experience if you're doing that for a couple of hours straight, and that's one thing that the Rift S does win in my opinion. As a developer headset, it's really good. I like the index more when I'm actually playing games. So I've actually played Half-Life Alyx with both the Rift S and the index just to see what the difference is. And as gameplay itself, yeah, you got a little bit more finger tracking on the knuckles. And these things, these were the biggest surprise for me, by the way. This is the biggest selling point for the index. These things are brilliant. I love these. And I was surprised by that because I thought that the touch controls, the original touch controllers, were sublime. They're really good. And these look bulky, right? They're twice the size of an. It's too far right. These things are twice the size of a touch controller, but they're light. They don't weigh anything. So yeah. Although the same thing for these goes with development, right? You know, you put these on and you strap yourself in, and they stay on your hand. Brilliant when you're playing. When you're developing and you're constantly putting them on and off, it's a nuisance. So yeah, when I look at playing, I prefer the index over the Rift S. When I play a game like Half-Life Alyx, I love it. But if developing, I definitely prefer the Rift S. When I look at the Quest, I love the Quest. Brilliant. Quest is just a very different beast, right? Because you're mobile, you don't have the power that you have on a desktop, so the fidelity is a lot less, but you've got the freedom that you can play anywhere you want, right? I'm in a relatively small room here. Luckily, I've got the index somewhat permanently set up, but it's still not ideal. And a lot of people don't have, you know, that dedicated space to set something like that up, which you really need when you're working with sensors. With the Quest, a friend of mine plays his Quest in his backyard, and it works brilliantly. So yeah, I love that about it. All right. Yeah, yeah, that is one of the reasons I chose the Glass 2 driver here. Was I really wanted to be conscious of the performance side of it. Now, the mistake to make is because it's got nothing to do with OpenGL ES3, right? OpenGL 3 ES3 is not slower than 2; it's actually faster. The thing is that what Godot does with that additional performance, that is where the crux lies. So, Godot 3 really put a big emphasis on doing higher end rendering techniques, so like HDR, GI probes, all that stuff. And also considering that it was something that Jean built by himself mostly in record time, in like a year. There's a lot of areas for improvement, which is something that the move to Vulkan now has really allowed him to concentrate on, which is why the Vulkan build is crazy good. It does more difficult lighting techniques than the Glass 3 driver, and it does it faster. So I am very much looking forward to using the Vulkan renderer for it. But even there, the same thing goes, right? VR is a different beast. You're rendering at 90 frames per second. You're rendering two screens at the same time, so it's like rendering a normal game at 180 frames per second. What a lot of people also don't realize is you're rendering at much higher resolutions, even though the screens on the HMDs are, they're pretty good resolution, but they're not, there's not like 4K screens yet, unless you go for like a Pimax 8 or whatever like that, or I think even the Reverb now is a pretty high resolution, like 2K by 2K screens. But you're rendering at a factor higher because of the lens effect. So even with the index, which is, I don't know what the panel sizes are, but it's, I think it's something like 2500 by something. But you're rendering at a much higher resolution than that at 90 frames per second for two eyes. So there is a lot more performance requirement of the rendering. And the only way that you can get that is by not going overboard on what you're doing. So when you look at Glass 3, of course the whole weapons tutorial I have done in Glass 3, I have done with the GI probe on. On this PC it runs beautifully, it can really pull it. On that PC, if I'm lucky to get 50 frames per second on that machine, which is too low for VR, it gets you motion sick. It's just not what it's intended for. It's intended for desktop games. So that's one of the reasons why for this game I chose Glass 2, because Glass 2 does away with a lot of those high level effects. It's a much more straightforward renderer. I'm still completely impressed by the fact that most of the PBR logic is actually in there, and it's doing a pretty good job at that. There are some color issues because we don't do HDR, but it's getting damn close. And when you look at this type of game, a space game, who cares, right? You got a sun that lights the whole scene. We don't have dozens of lights that need to do all sorts of funky things. We'll eventually have some more lights and do some more effects with lights, but most of it is just your single directional light lighting your scene. So and the other thing which is really nice about space is that most of your screen is black. Most of the things that you are chasing are far away from you. You might be chasing one ship that you are trying to fire, maybe two in the situation like here where you're targeting an enemy and he's got his wingman on his tail. you're not rendering that much in space. That's what it really comes down to. So that's where I hope that even with some high quality assets, we're still going to get a pretty good frame rate out of it, even on my lower end machine, which I totally haven't looked at yet. It's too early for it. Put more effort into ease over and over. Well, again, I think a big thing is that when you are playing a game, when you're playing a VR game, you're wearing your headset for an hour, 2 hours, 3 hours straight. So having a headset that, because one of the downsides of the Rift S, as a developer, I love the Rift S. You put it on, you take it off, you put it on, you take it off. It's comfortable. But because it's not a ski mask design, there's a lot of light leak that comes in from the side. PSVR had that same problem. There's a lot of light leak coming in from the from outside. So as far as immersion goes, a design like this, where you've got the whole thing just locking your face in place, from a gameplay perspective, and it's the same with the Quest as well, which does the same thing. That is ideal, but from a developer point of view, it's not. So it's a choice. What is the vendor going for? Is the vendor targeting the handful of developers that make games, or is the vendor targeting the consumers who actually going to play those games? And I think that really dictates the design. So I can kind of understand that choice. Yeah, Game Drake, indeed. If you get tired of taking the headset off all the time, then try and code as much as you can, and you'll be debugging a lot more. Again, it's one of the you get used to it. Let's be honest with that. We've been streaming for 3 hours. I've been working on this for 3 hours, and I've been taking the headset off on and off for 3 hours, and it's doable. You get used to it. Yeah, that's true as well. Very often I'm just holding this down like this. Although you do tend to block some of the sensors, which can lead to problems. Or which is pretty nice with this sort of game. Sometimes I just leave the headset off and I'm just using the preview on my desktop. Which works very well when you're just trying to see if things work. When I'm trying to actually fight, even with the NPCs not doing any sort of dodging or anything like that, that's when you really do want the headset on, because you really want to be able to see what you're doing. Yeah, two 1440p LCDs. That sounds about right. But still, that's slightly over HD resolution. I think it's a similar resolution to what the MR headsets have as well. So they're slightly higher than the first generation headsets. But it's nowhere near 4K yet. But you are rendering at 4K. If you look at the size of the actual render buffers that we're using, they're much higher. They're 2K by 2K buffers, I think. Multiplayer online games. So multiplayer is a subject on its own. Now, one of the things that I am thinking about, I'm building a single player game here. That is my passion. One thing that I think is a sad affairs in VR is that so many of the VR games coming out right now are purely multiplayer games. For me, the biggest example in this area is Eve Valkyrie. I played the single player mission that was on the demo disc, which I absolutely loved, absolutely fell in love with the game. And then when the game came out, the campaign was nothing, a real letdown. As a multiplayer game, it was incredibly good, but it's not enough, especially when you get into a position where a lot of the people who play a lot just become a lot better, which means that for everybody else, it's just they just die, and they give up on a game and they walk away. And in itself, that's not a bad thing. You know, there are some really great multiplayer games that are absolutely beautifully done in VR. But I think to capture the market, having more campaign-based games like Half-Life is a good example. Boneworks is another good example. I think those sorts of games, the more you've got them, the more enjoyable it is for a lot of people who are more casual or who just want to, play through a game and put the difficulty level to something that they can do and not constantly go up against really good players. That's really, I think, something that's missing. It's also why I'm really looking forward to the Star Wars game that's coming out, which supposedly is going to have a full campaign mode as well. That said, when we look at something like this, for instance, we're already building some NPC logic. To get to a point where we have a campaign system and we're working out all the kinks of things, we're going to be months down the line. So one of the things that I have been looking into is using the built-in multiplayer system that is in Godot. There is a networking API in Godot itself, where you can run one copy of Godot as sort of like a server. I am planning on giving that some attention probably in a couple of weeks. Probably when we're far enough with this that we can actually use most of the weapons properly and have all the controls in there and all that sort of stuff. I am planning on doing a very simple multiplayer implementation in this, just for fun. Not even sure if it's going to end up in the final game, but it might be something where, when it's working, I'll put a build up somewhere and you guys can download it and we can do some little skirmishes or something like that. That's what I've got in my back of my head right now. So it's something that I do want to spend time on. Yeah, I actually haven't even tried my my index at 120 hertz. I've just been running it at 90 hertz, so it's definitely something that's going to be interesting to try out, especially on this machine. This machine should be able to handle it quite nicely. Yeah, I have the same opinion about all the MR headsets. I got the Acer one, which has a horrible strap. But when I got that one, it was one of the higher resolution headsets that you could have. Microsoft went higher panels pretty quickly. You obviously had the Samsung Odyssey, I think it was called. That even went a step higher. But even just the standard Acer and Lenovo headsets and the HP one, they already had a pretty high resolution. So as far as the headset itself is concerned, they are beautiful, but the controllers are horrible. The tracking I was actually pleasantly surprised with. Obviously the Rift S is, and the same with the Quest, with the 5 cameras, their tracking is so much better than MR was. But that's 1.5 years of technology. So for what the MR headsets offered when they came out, I was really impressed by how well they worked. But the controllers are horrible. And I don't get it. I don't get why there isn't any progress being made. Now, I did see photos of the new HP Reverb, where it looked like they did do a bunch of improvements to the controllers as well. But don't know. I actually need to Testa did a video on them like a couple of days ago. I haven't watched it yet. So I'm planning to have a look at that one probably this weekend. But yeah, that was the real letdown of the MR headsets. Other than that, I love the MR headsets. They are actually bang for buck. They're probably one of the best headsets. If you really look around, you can get them for something like $250, $300 US if you're lucky, which is quite a bit cheaper than a Rift S. So yeah, as a budget solution, if you look around, they're really good. The controllers, yeah, they're meh. Yeah, that's the other thing. Again, the Acer was such a letdown with the band. And actually, I need to get a new band because the band broke, which is a bit of a shame. But one of the things that I absolutely loved about the Acer was that flip up, right? So when I got I used the Acer as my primary development headset for that reason alone, for at least a year. I think I didn't swap until I got the Rift S, um, because you just put it on your head and you flip it up and you work, and then you flip it back down and you test, you flip it. You're not even taking it off anymore. Again, the band was as uncomfortable as it gets. I know that for the Lenovo and the HP ones, the bands were a lot better. So that was just because the Acer, and I don't know if the consumer version was any better, because I got the developer version. Microsoft sent me one, which was really cool. Um, but yeah, as a developer headset, I love it. It's yeah, it's that the controllers let you down. That's a real issue with the MR ecosystem. Um, and I think that'll go. It's I found Microsoft's decision making when it comes to VR really weird. The fact that they don't have VR on Xbox, well, they've got all the components ready to go. Xbox is running what's it called, Universal Windows Platform, uh, DirectX on it. As far as I'm aware, in theory, you plug in a WMR headset on that thing, and it should work. I don't get why Microsoft didn't go down that path. Yeah, it's a shame because they actually have some really strong, or they had some really strong hardware when the WMR headsets came out. They actually had a bit of a lead on Oculus and HTC at the time. Valve, of course, didn't have headsets yet. I don't get it. I think Microsoft missed a really great opportunity in the VR space there. But yeah. Um, when you look at value of hours of unbroken experience, I'm of two minds. On one side, I still actually have to finish Half-Life Alex. I'm about probably 80% through. My main problem there is just not being able to just say, well, here's 2 hours that I can use this space without being interrupted, and just play through the last bit of the game, which is a bit of a shame because I love that game. I think it's a brilliant game. But that is the type of game where I could easily spend 2, 3, 4 hours just playing. Although I do have to say that one of the really interesting things is you get really tired after 2 or 3 hours of playing in VR because you're standing around, you're walking around. While, of course, when you normally desktop games or console games, you're sitting down in a chair or on a couch. It's a much more relaxing and not tiring experience. So I think that there lies a challenge for VR to do something with. I fully agree with you on your point of the high fidelity. You know, PSVR is the lowest resolution headset out on the market. Yet, any game that you play, the only thing that lets you down is the tracking. The tracking really sucks. But when you look at some of the games that were built with that in mind, you don't notice that the resolution sucks after you're busy for 15 minutes. I think the gameplay more than makes up the quality, and even on the higher resolution headsets, right? Even if you look at the Index, or if you look at the HP Reverb, you look at the games, all the games are still relatively simple graphics, and that's how much fun. You look at a game like Super Hot, there's no need for high fidelity there. But it's a brilliant game. Beat Saber, biggest selling VR game of all time at the moment. There are freaking blue and red blocks flying to you with a glow effect. For me, Robo Recall. Robo Recall on the Rift was Oculus taking things to the max quality-wise, and then they reproduced it on the Quest, and they had to really tone down all the quality. It's still as much fun as it is in the high quality. So I get it for the HP reverb. I was looking at some of the interviews that they were giving, where they really were trying to position the HP reverb for business purposes, where it was important that you could read text on things that you picked up and stuff like that. So there, the high resolution, the high quality is really important for that niche. But I think for general gaming, it's you can make a great VR game when you concentrate on the playability, on the gameplay, and keep your graphics simple, and people will love it, because it's hard, because it's a hard sell, because when you see the screenshots and when you see the videos on YouTube, people don't get enthusiastic about it until they put the headset on and they experience it. You look at budget cuts, or what's a game called? It's on tip of my tongue. Where you need to do all the shop things with the robots. My kids love that one. I can't remember what the name is, but simple graphics, but so much fun to play, and because it's all physical, you can't do that in any other medium. Yep, absolutely. I think Beat Saber's success, the fact that it avoids all the problems with VR, right? It avoids indeed the problems with multiplayer, that you need to be of a similar level of the other people that you're playing with. It doesn't have anything with motion sickness, because it's a fully tracked game. You're not moving. Same with Space Pirate Trainer, for instance. Fast-paced, really fun, but it's all natural movement. So many things that make those games show off all the VR strengths without any of the negatives. That's why these games are so successful. Hey, Thayton, how you going? Yeah, I wonder about that. Why they chose whether the visual LEDs were just for show, or whether they actually are part of the tracking. Yeah, interesting. Yeah, I agree. It's after 3 or 4 hours of playing a game like Alex, I want to sit down for a couple of hours. But other than that, I could use the exercise. That's for sure. Yeah, I remember the set. I never played it though. That was a shame. I was living in Holland, and for some reason the whole VR craze never really um, was accessible, which is a bit of a shame. So I missed it. I only read about it in the game magazines. I never actually got to experience it. It's a really shame. Yeah, I lost Superhot is such. I'm still so surprised that Superhot started life as a desktop game. That whole premise is so perfect for VR. Um, yeah, and anybody who wants to get into VR needs to try Superhot. It's just such a good game. Yeah, Job Simulator. That was the one I was thinking about. Where yeah, my kids can play that for hours if they get the chance. Yeah, that's Half-Life performance. I don't know how they did it. I really don't. When it finally came out, I was having problems with this machine. I actually had the hard disk of this machine go out. Weird story. So I actually started running Half-Life on my Metabox, which isn't a slow machine, but it only has a 1060 or 1070 GTX, and it runs Half-Life without missing a beat. And that's also when I played it first with the Rift S, I think. And then when I got my Alienware back up and running, when I finally got my my new SSD to go, I hooked up the index and never looked back. But I was really surprised at how well it still ran on my Metabox, which is definitely at the lower end of the spectrum of what you should have for VR. Yeah, the reprojection does help a lot. That really saved me with this laptop and doing the original weapons tutorials and stuff like that. Because, like I said, I was lucky if I got 45, 50 frames per second, and the reprojection bumped that back up to 90 in the headset, and it did it good enough to not be a problem with tracking. Although I have noticed that that's probably the only thing that's a problem with Oculus, because of the tracking being based on camera images where the tracking is being done on your PC. You do notice that if it goes wrong, it really goes wrong. I had some really big problems with the Rift S on this older machine when I did screen captures. One of the reasons why I got the Elgato to actually capture the screen, because with already all the camera images going over the USB, it's crazy stuff. I don't know what exactly went wrong, but it's yeah, I couldn't really see half the stuff that I was doing in the headset when I was recording some of that stuff. It's fine when I wasn't recording, run fine, but when you started recording, it was completely screwed up. Anyway, I'm now doing it with external capture, so all good. Okay, is that why my batteries run out on the VMR controllers? Okay, although I have to say that the batteries on the touch controllers don't last that long either. Then again, it's only one battery. You have to have two batteries on the VMR. So yeah, what I find really strange about the touch controllers is that it'll drain the battery even when you're not using it. If I leave my touch controllers just lying around for a week, they're completely out of battery. I'm not quite sure if that's something wrong with mine, or if that's just how it is, that they still keep using power. Yeah, one of the things that I think is also important is that they've got that. Where is it? Video. Yeah, it's the automatic render resolutions, where depending on how much performance you have, it will actually up or change the resolution under which you're rendering. So on a lower GPU, it might put the oversampling down, and you might get a little bit more pixelation, which you will only notice if you need to read text somewhere. So maybe that's where you can see that on the lower end machines, it just lowers the render resolution, and on the higher end, you get higher higher rendering resolutions, but as a result, the frame drops from time to time, and some of the more complex scenes might be the same. I don't know. But all in all, yeah, I am so impressed with Half-Life. I think it's it's not for everybody. You gotta like that sort of game, but I think it's just such a good showcase of what you can do with VR. I still need to play Boneworks. That's the other one that's still on my list of things that I want to play. So yeah, there's some really good games right now, which is really cool. Anyway, what time are we living right now? It's 12:30, so I think we're going to slowly put an end to things. Yeah, I think we've got the makings of some NPCs here. It's really cool. I'm probably going to add the same to our friendlies, so that they can actually patrol around our carrier and then attack the enemy ships if we lure the enemy ships closer. That would be cool. But I think that the next step next week, during next week's stream, is going to be having the enemy ships target us when we get too close to them. So as long as we're not close to them, they're going to be following their path. And we're probably going to move them further away again because we do want some range on them. But then when we get into range, we're going to get them to stray away from their path and start attacking us. And I think that's going to be something that we're going to be breaking up into several parts, where we're going to have some fun with it switching between different states, whether it's attacking us, whether it's fleeing away from us, whether it's dodging. Not quite sure yet how we're going to be doing that, but I hope this week I'm going to have a little bit more time to clean some of this up. I might actually improve the missile logic a little bit. I definitely want to do more about the heading logic to get the enemy ships to fly more naturally. So I'll see if I have some time for that this week before the next stream. So that next stream we can head straight into getting our NPCs to attack us. I think that's going to be the subject of next week's stream. Yeah, I've seen Ben VR play a couple of the scenes or a couple of the levels in Boneworks. It looks really cool. I don't know enough about it other than that it's been getting a lot of hype about how good it's supposed to be, and a lot of people saying, well, it has better interactions than Half-Life. Half-Life is too old, and I think that is one of the things that I find really interesting about the whole discussion around Half-Life, and also about the whole discussion around VR. When you look at things like Beat Saber and you look at things like, Job Simulator is already a bit bigger, but these are the type of games that you can build in like a year, right? Because they're built on a single premise, and there's some scripting involved, especially with Job Simulator to get some more content in there. But it's still fairly basic. It's just a very good concept, very well executed, and that is what makes it so incredible fun. But when you look at a game like Half-Life, you're talking about something that requires a large team to work on for a long time. And this is something that we very often forget, with all these AAA titles, also on desktop games. These are games that take 4, 5, sometimes 6 years to create. So the fact that they created Half-Life in the period of 3 years, um, I'm guessing that it took about 3 years, and probably around that time that they started on it, is quite amazing. That they created something that's that well executed. But as a result, that means that a lot of the design choices of how the game works, how the game interacts, were all made probably 2 years ago or something like that, or that they would have been solidified around that time. So you can't suddenly say like, hey, in these last 2 years someone's figured out that this type of locomotion is better than a teleporting, or this kind of interaction with guns is better than the what they came up with. At some point in time, the way that that game worked was set in stone, and then you start, then the big time span starts to actually get high quality content in a game like that, and high quality story in a game like that. So I think when you keep that in mind, that these games take that long to develop, it is an incredibly well executed, beautiful game that has really good interactions. While when you look at Boneworks, they had the advantage of being a little further down the line when they started working on that game, that they could do more with it. And I think people forget that. And I think one of the things that VR suffers from is that a lot of people look at, there's so many existing games, so many existing franchises out there, that when you create a game for this, everything is known. How you build games on desktop, everything is known. So it's purely about designing the game that you want to build and getting a team together and getting the people with the experience together to build that game. While in VR, it's not just building a game, it's everybody learning from scratch what they want to do, and especially unlearning what they want to do. Because when VR became popular again 3-4 years ago, everybody wanted to do an open world walk around game like a Fallout or GTA in VR or something like that. But then the problem starts is that's the type of game that VR suffers from, right? Where you suddenly have the locomotion problems, the fact that you can't walk across a landscape without people getting motion sickness, because unless you physically walk, you're constantly battling what your brain wants to interpret. So then you have to go with teleport functions and stuff like that to teleport around, and that suddenly changes your gameplay mechanics and how that all works. So a lot of things had to be unlearned and relearned to figure out how to do things better in VR. Now, again, games like Space Pirate Trainer and Beat Saber and that sort of games, they just worked around that by simply saying, well, we are going to have a player with a limited amount of space, so we're going to design a game that works in a limited amount of space. We're not going to teleport around and have all the motion sickness issues. We're going to have the persons stand somewhere, and whatever they're interacting with is going to fly towards them, whether it's blocks in Beat Saber, whether it is the enemies floating around in Space Pirate Trainer, or whether it is like Super Hot, where you're still also moving in a very small space, but your game mechanic is time. These games all work, but they also all work because they are all centered around a single principle that they've then executed really, really well. When you want to look at a AAA game where you actually want to move through a whole storyline, all of a sudden you have to solve those VR issues, and that takes time. And we're not even there yet. Half-Life Apex, I love it. There's a lot of people who love it, but there's still a lot of people who can't play that game because they get motion sick, or they have problems with the speed at which things happen and stuff like that. So yeah. Yeah, like I said, Gugarts, I think a lot has to do with the fact that it takes a long time to build a game like Half-Life. So the methodologies that they use in the game for interacting with things were designed at some point in time, and a lot has improved since then. A lot has been learned, but you can't suddenly retrofit that into a game that takes that long to build. So yeah. Yeah, and everything's moving very quickly because it really is a new world that we're learning, and people are coming up with new ideas and new solutions to problems every day. So, and eventually there's going to be a affordable locomotion solution um, that will actually work. Right now the ones that are on the market are really expensive and they're still kind of dodgy. Um, so yeah, you got to work around teleports and stuff like that. So yeah, the climbing ladders is indeed, um, yeah. That one's actually really weird because one of the things that I found immensely interesting was the game called Robinsons on the PlayStation. It was one of the launch titles or early VR games on, and I that game I've always had the feeling with that these guys were very early VR adopters. Then and they got involved with Sony for whatever they did, very early on in the development cycle. Um, but they still only had a year and a half, or something in those lines, I think, to build that game. And you kind of notice that because it's a really beautiful game, but it felt like they cut out a lot of stuff because, or they cut the story short at some point in time because they just ran out of time. And the same with the UI. Everything in that UI, everything the way that the game is set up, shows that it was expecting to be played with controllers, with track controllers, but it's not. It's a game you play with your gamepad. But that all said, as early as that game is, they got so many things right in there. It's also a great game if you ever get the chance to play it on the PlayStation. And keep in mind, if you play it, that it is one of the early release titles. Visually, I the first time I played it, I had seen some videos about the whole premise, and it looked like a bit of a kiddie game. Little kid with his pet Tyrannosaurus. Um, and indeed, the first half hour of the game kind of feels like that as well, because you're just exploring around. It's this beautifully made world where you've got these dinosaurs running around, but they've got a lot of the mechanics right. They've got the climbing mechanic right, even though you're using the freaking controller or the gamepad. They've got a lot of the movement things right for such an early VR game. But then the whole game changes halfway through, and it's changes from this cute little I'm exploring this world and doing all sorts of things with dinosaurs to all of a sudden I'm being haunted by or chased by raptors, and it turns into a half-hour horror game. Yeah, lovely game. I can really recommend trying it out and keeping in mind that it was probably rushed through, but even then, it was still a pretty damn good game to play. Arm swingers? What do you mean with arm swingers? Um, well, I think two lots of these. I think that goes for any game, doesn't it? We're always going to be faced with different games needing different mechanics and having mechanics that don't work for every game. So that's, I think, pretty normal. It's more that right now we still don't know a lot of the mechanics that work best in VR, or how to work around the drawbacks of some of the mechanics. And I think that's going to be the learning experience, where when we look at desktop games, we've got 30, 40 odd years of experience of how these games should work. And of course, with 3D games, it's then 20 years of experience that we have figuring out how to. A good example, I think, is Tomb Raider. You play the remakes of Tomb Raider and how well the control mechanics are in that, and you compare that to not like the first Tomb Raider, which was really, really brilliant, but like the third or fourth, Tomb Raider Legends, I think, was one of the good examples where they suddenly had a lot more freedom in the 3D environments and moving around, and as a result, the camera mechanics were horrible. It's all a learning thing, but today we have all that knowledge and all that experience about how to solve all these problems that you can potentially have in desktop games. So as long as you look at games that have solutions for these things, you can figure out how to make a game that plays really well and that's really comfortable for the player to play. And I think when you look at VR, we're not there yet. We have it for some games. We have a lot of games that work around it. One of the greatest examples for me was actually Farpoint on the PlayStation, just a game that the aim controller came out with, which is an okay game. It's not great. It's nice. I love playing it. It left me a little bit longing for more. But before I played that game, I didn't believe FPS was possible, especially not on a PlayStation, because you didn't have the tracking, you didn't have the precision required to make a game like that work. The aim controller to some extent solved that, but what I found really special about that game is how well they worked around the limitations of the PlayStation VR. So the whole game makes you move in a fixed direction so that you're always facing the camera without you feeling that you're always just going in one direction. The way that their level design works, that you're still turning around corners and going always in different directions. It's all an illusion by very good level design. And again, that's just, hey, here's a group of people who had a singular problem to solve. The fact that they wanted an FPS where you're moving, and they didn't want to deal with the fact that they didn't have 360-degree tracking, because if you can get 120-degree tracking out of the PlayStation VR, you're lucky. But they still wanted to have that sort of experience. I thought that was really well executed. But I think it's that sort of stuff, that sort of thing that where VR still has a lot of ground to cover before we have solutions for all those different problems, so that you can build a game and you can put the right solutions in place to make those games enjoyable for most people. I haven't heard of the entertainment, so I got to check that one out. Oh, but it only works on the Rift DK1. Okay, so I'm too late checking that one out. Yeah, and indeed, when you look at very early titles, there are some that I still recommend, especially on the PlayStation, because I think they're really good examples of things done right. Or how where it all started and what sort of thing. But yeah, when you go back to DK1 days and DK2 days, yeah, I can only imagine that those VR experiences do not hold up today, if they even still work. Well, when you look at intuitivity, that's the thing. The selling point for VR is we haven't figured out yet how to do certain things, but the intuitiveness of the games are sublime. And for me, my kids were the biggest indication there. Where when VR came out, when it started, when I started getting involved in it, was probably 4 or 5 years ago. Maybe even longer, maybe 6 years ago by now. I could be wrong. 5 or 6 years ago. Anyway, that was before I had headsets myself. I used to be there used to be a meeting at the local university here, or the local TAFE, for budding game developers or people who are doing game courses. And there were a couple of guys who had VR hardware who would bring their VR hardware around, and we would be playing DK1 games or DK2 games. And then at some point, someone that must have been 3 or 4 years ago, because one of them brought the HTC Vive pretty much the week that it came out, and brought it in. And my son must have been, he's 11 now, so yeah, he must have been 7 or 8. And the headset hardly fit on his head. But he put it on, and they started Job Simulator. So that'll give you probably a better idea about how long ago that was. I'm terrible with time and dates. But anyway, he put it on and, got the controllers, and he just started playing the game. And, I was having trouble getting him to play things on consoles or on a PC because he didn't understand how to use a mouse. He does now, but back then he's used to iPads, right? iPads are easy because you touch things with your hands, but then you move a mouse around, and this thing that you've got over here, for us it's natural, right? We know you move a mouse, the cursor on the screen works, but for him it was like I'm not touching it, I'm not interacting with it directly. But you put the VR headset on and you give him the controller, and he immediately understood that his physical interactions directly affect the world that he's in. And that immersiveness, that direct interaction is what, in my eyes, makes VR so great. And where, the top VR games make good use of. That it's this fact that you're physically moving and physically interacting with what you're doing. While with everything else, there's a stand-in thing. You're using a gamepad to control a character. You're using a mouse to look. There's a disjoint there, and yeah, I think that is one of the things where I do believe that VR offers something that, once we utilize that properly, and I think we already have, with games like Beat Saber and that sort of games. Box VR is another good example. Or even something like this, right? This is, for me, when I look at something like a space game, which is underutilizing VR to such an extent, right? I'm still using a joystick because that's the natural input device for controlling a spaceship. So you're really only using the VR headset so that you get a perception of depth and you can look around. But even that small change in a game like this makes such a huge difference compared to playing that same game on desktop. I think VR has got a long way to go, or a bright future ahead of itself. That's the expression I was looking for. Play as a gecko. Okay. Camille, that sounds like a really interesting experience. Mm. Okay. Yeah, no, joysticks is the only way to go with Space Sims. Obviously, I'm going to be able to fall back on gamepads. I also want to go the other way. Doing full HOTAS setups. Once I'm a little further along, I'll be talking to Ben, who's one of the other OpenVR developers in the Godot team. He's got an amazing flight sim setup at home. So obviously, I want to see if I can push it that far as well. My dream, if I ever have the space for it, is actually building a proper cockpit and then having all the control services where they are also in game, so that you have that one-on-one relationship between those things. But that's the geek in me, right? That's not really the sensible as a goal for the game itself. But yeah, joysticks is really the way that you and even with this one, because the throttle is just a little thingy on it. I much rather have the proper HOTAS where your throttle is on your left hand, your controls is right. Maybe eventually even having rudders, using your feet. Who knows? That would really for immersiveness for a space sim. That would be really cool. So that's definitely something that I want to at least make possible to make use of in this game. Hold on. Sorry. But yeah, at the bare minimum, it needs to be playable on a gamepad. Keyboard, doesn't work in my eyes when it comes to VR. There are people who do. There are some people that I know who are so good at feeling, the mouse and the keyboard without being able to see it physically, and still be able to play games that for them that would probably work. It was actually one of my biggest problems that I had playing, what's it called, Starfighter Redux, which is the game the people made, that the guy who made the original cockpit that I was using, Sean something. They've got a Wing Commander type game that's on Steam, and they made a VR version out of it. But you can really notice that they took the desktop version and they added VR onto it, and it's trouble because you just can't support all those buttons in a way that that works if you don't design for it. And that's something that I'm very conscious in what I'm building, is I really want to make sure that you can play games with just the basic control that you need, and everything else becomes optional. Because some people might have a joystick, but they might not have a joystick like this with the 10 buttons that I've got access to. They will just have the primary, fire, secondary, trigger, maybe 3 or 4 extra buttons, and that's it. So I need to make sure that is possible, because for most people, once they put the headset on, you can feel for your joystick, and once you've got your hand on your joystick, you can work. But if you have to figure out which button to press without being able to see the buttons, that just doesn't work. So yeah, that's going to be interesting. Yeah, driving games is it's one of the reasons why I started with the vehicle tutorial, because that too is actually a game that really works pretty well in VR. The biggest problem, I got Drive for the PlayStation, which my daughter absolutely loves. She loves playing that game. The biggest problem that you have with driving games in VR is when you crash. Because when you crash into another player or you crash into a wall, you change direction very suddenly, or you come to a standstill very suddenly. So while acceleration, because you're still grounded in the cockpit, your brain, or most people's brains, will accept it. Suddenly stopping while your brain thinks that you should still be moving forward, yeah, that doesn't work very well. it goes wrong very, very quickly. And that's of course, the space. We don't have that problem. We're not going to hit a wall. We might hit an asteroid, and that's where you do get sick in the current version that I have right now. If you hit one of those asteroids and you start spinning around while you're just sitting still in your chair, it's a weird sensation. But again, it's all about the design of the game, and we're not even that far along with things. Where eventually I'll find ways to not overdo that sort of out of control spin, because in the end, we're not supposed to be flying into asteroids, right? The asteroids, you really want to stay far away from them. So, and a good example for me is the X-Wing Rogue One demo on the PlayStation, where you're flying through the asteroids. They've set a good path out, and there I think if you do hit the asteroid, you don't get knocked off, you just die. So that's one way of solving that problem. The chicken thing sounds really interesting. And yeah, I can imagine that some headsets have problems looking down. It's interesting how that form of tracking is often one of the places where it goes not that good. I haven't played Everspace in VR. I have played Elite Dangerous in VR, but then with a gamepad, and I thought that was really well done. Although I think when I played it originally, that was still on an early beta, and they had done that really well. But then by the time that the full version came out, they had tried to put all the features in. So you obviously don't have enough buttons on a gamepad to support everything. And while in the original beta, they really stuck very well to that whatever screen you're looking at, you get context sensitivity. So the buttons change depending on where you were looking and what the functions were. But eventually they ran out, and they had things that you had to hold down buttons, and then it got a pop-up menu and stuff like that, if I remember correctly. And that was really weird as an experience. But yeah, trying to then figure out how to then use your keyboard while you can't see your keyboard, I don't see it working. So I want to be very careful in how I design my game around that. We'll see. Yeah, exactly. It's the original beta that they did. They managed, but with a full game, it was weird. Yeah, well, when you crash into a wall, you probably should feel a little sick. But I'm not sure that people want to play games for that. I don't know. Oh, okay. So the headset falls off when you're looking down. Okay, I hadn't thought about that. Um, yeah, that I can see that some headsets have problems with that. Yeah, that's something that actually that was my only remark also about the Acer headset. Was that that was not a headset that you could move around very quickly with, because the head strap just didn't have enough grip on your head to make sure that it didn't fly off into directions. Um, so yeah, and that I have to say that the design, like the index, this thing does not come off if you put it on properly. It is sitting very solidly on your head. And I think with the Rift S, you would probably also have problems if you move your head too quick. It could very well fly off your head. But yeah, it's design around the things that you have. Anyway, guys, it is 1 a.m. That's an hour over what as long as I wanted to stream. So I'm going to start putting an end to it. That was, It was actually fun. We just chatted for the last hour. That was really enjoyable. Just throwing some VR ideas around. Yeah, guys, lots of thanks for you guys joining in. It was really enjoyable talking to you guys and throwing some ideas around. I hope you guys enjoyed what we did tonight on stream. I think we made some really cool progress. We've got the beginnings of some simple NPC AI. So yeah, I think that was well worth the exercise. I'll be working on the tutorial, and if time allows this weekend. Depends a little bit on how things go with the kids. But if time allows this weekend, I'm hoping to release it probably on Sunday, Monday the latest. Obviously, those plans can change. That's the downside of having other responsibilities in life as well. Downside. I'm happily have those other responsibilities. But I'm going to try and see if I can get the next tutorial out before the weekend is over. And then we'll see next week where we are with this little project. So like I said, I am probably going to spend some time improving the missile logic and some of the turn logic in here. And then next stream, we're going to start looking at the NPCs actually attacking us. Yeah, see if we can actually get shot down a few times. So yeah. That was I think it was it for the stream tonight. Thank you all again. Yeah, more than time sleep. Like it's 1 a.m. here. It's late, it's dark. Everybody in the house is sleeping already. So yeah, cool. Thank you again all for watching, and I will hopefully see many of you again next week. Have a great day if it's daytime. Have a great night if it's nighttime. And I'll talk to you guys later. See you.